Hi everyone and welcome back to my channel. So today we'll start the marathon of step and impulse response of first order RL circuits for voltage excitation. Okay, so this will be very interesting session, and like currently what is happening, obviously RC circuits are important. RL circuits, the importance of RL circuits is also increasing. So make sure that you don't miss this video. Okay, so like what is my demand, this will be a long marathon, and I will cover most of the first order RL circuits, but my demand is you have to like this video and I will give you a like target. So you have to at least get this video to 150 likes within next 72 hours. Okay, so if this video gets 150 likes in the next 72 hours, then I will keep this video, else I will make this video private. So it's totally up to you, right? Like I'm doing this much of work, so you have to also support the video also. Okay, and like you can like and share my LinkedIn post. I will share it in LinkedIn about this marathon, and obviously I want you to study as well, so you study, right? So these things you what I expect. Okay, attend the good attendance and obviously liking the video. Okay, so let's start the marathon. So first of all, also right, I will bring a marathon for current excitation as well. This one is for voltage excitation. If this video gets enough reach, enough likes, so I'll bring it for current excitation as well, else I will not bring it. So the question is, you have to evaluate the voltage waveform and the current waveform, basically the output voltage waveform and the output current waveform, VO and IO, for unit step and unit impulse voltage. Note that the inductors are initially unenergized. So these are the circuits and you have to plot the VO and IO. Okay, so like you can solve it for yourselves, then you can see the solutions, or you can solve along me each circuit at a time. So let's first solve this. Obviously I will give you two approaches. First one is the intuitive one, and then obviously we'll do the calculations. Okay, from there we'll understand. So this is the first circuit, simple series RL circuit. So for the first one I will go slow. Okay, I will tell every points. For the next few circuits I will obviously go fast. Okay, so the first one is just a warm-up thing. So if I copy this circuit, okay, so how will I start? First of all, I will see like whether this is first order or not. For us to check the order of a circuit, we have to check how many number of independent energy storing elements are present in the circuit. So here only one energy storing element is present, that is the inductor. Inductor can store energy, right? It has to discharge also, it has to discharge energy, but it has the ability to store energy. So here only one element is present, so my number of independent energy storing element is 1. Okay, so as this is first order, everything will be 1, but how, like there will be 2 energy storing elements as well, but still there will be 1. That is the most important. But how will you explain those as a single quantity? That is important. So obviously I will have, like if the number of energy storing element is 1, order is 1, that means I will have a single pole. Okay, and if I have a single pole, that means response will be exponential. Okay, response will be exponential, like this. If you just watch my sequence, start from my RC transient response of unit step and impulse, there I have explained why the response will be exponential. Just hold on. Okay, so now like for it, as it is exponential, we can find the time constant of the circuit. What is time constant of a circuit? For a first order circuit, time constant of a first order circuit is L equivalent upon R equivalent. Okay, so obviously here I have only single quantity, so it will be L by R simply. Time constant will be L by R. So like what will happen intuitively? Let's understand what will happen. So first we got the point that we got to this point that this is a first order circuit, response will be exponential. Okay, and I know the time constant. Now we can intuitively say what will happen, right? We can save the intuition for first order circuits. So obviously if let's say I'm applying a unit step, if I'm giving a unit step, initially inductor is unenergized, so current through it will be 0, flux is 0, current through it will be 0. Okay, as like I will say, initially inductor has no charge, initially L has no flux, so psi of 0 minus equals to 0 and psi is equals to L times I of 0 minus. So I of 0 minus will also be 0. Okay, I of 0 minus will also be 0. Now if I of 0 minus is 0, that means initially it has no current. suddenly I gave a voltage over here. Let's say I give unit 1 volt, right? Then this has no current, so this doesn't want to change its state, right? Inductor doesn't want to change its state. It doesn't want to change its energy at that point of time. So here there is some 1 volt and it doesn't want to change its voltage because there is some finite voltage applied across the inductor. So it will be same as I of 0 plus. Then what will happen, that as current is 0, overall 1 volt is applied across the inductor. So if finite voltage is applied across the inductor, so VL is positive. So VL 0 plus is positive. Okay, VL 0 plus is positive and it is finite. As it is finite, okay, 1 volt, because here current through this is 0. Okay, hence that's why the current doesn't change as the voltage is finite. We'll understand when we'll do the impulse response. So VL 0 plus is finite, which is also greater than 0. Now if VL is greater than 0, then the flux across the inductor will increase. Why? VL equals to d phi by dt, right? The voltage is equals to minus d phi by dt, or d phi by dt you can say, so without direction. So it is d phi by dt. So as VL is positive, so d phi by dt is positive, that means it will increase, right? D phi by dt is positive, hence phi will increase. Slope of phi is positive, hence phi will increase. Similarly, you can say VL is equals to L d phi by dt. L d phi by dt, not d phi, sorry, di by dt, L di by dt, current across the inductor. As this is positive, so dIL by dt is positive, slope is positive, so function will increase. Okay, slope is positive, function will increase. Okay, then what will happen? So current will increase, right? Current will increase. As current is increasing, this drop is also increasing. As this drop is increasing, here the potential across the inductor is decreasing. So the rate at which the current is increasing, that is reducing. So what will happen at steady state? At steady state, basically initially, initially what is happening? Let me draw the initial part of the circuit. Okay, I haven't drawn it, so else how will you understand? So initially current through it is 0, right? So this will be the initial portion of the circuit. This is V, this is 1 volt, and this is at t equals to 0 plus. Okay, and this is simply like the inductor, and voltage across the inductor is VL, and current through it is 0. We know at t equals 0, current through is 0. Okay, so obviously the voltage, this overall comes across this VL, and VL is 1. Okay, so flux across the inductor will increase. Then at steady state, what will happen? Steady state, if it has reached steady state, the rate of change of current will not change. The current will not change as it has reached steady state, or dIL by dt will be 0. So if dIL by dt is 0, that means my voltage across the inductor at steady state will be 0, as my dIL by dt is 0. So how will the circuit look? Circuit will look something like this, that this will get shorted. This will be R, and this has been shorted because dIL by dt is 0, voltage 0, voltage 0 means short circuit. And obviously I have a source connected here, 1 volt. Okay, so obviously what is my output voltage now? Output voltage is 0, but like output voltage is inductor voltage itself. So initially inductor voltage was at 1 volt, and now it has gone to 0. So VL is equals to VO itself, right? VL is equals to VO itself. And what is my, like initially my current was 0. What is my final current? Final current is, here I have 0 potential, and here I have 1 volt across this R. So obviously across this R I have 1 volt, so it will be 1 by R. So IL of infinity is 1 by R amperes. Okay, so with intuition you did this, so now you can plot it, right? So my current is going from 0, initially I had 0 current, to 1 by R current. So the plot will look something like this. Okay, and it will be exponential obviously. Okay, and the voltage will go from 1 volts to 0. Okay, 1 volts to 0. So exponentially it will be something like this. So this will be 1 by R, and this will be 1 volt. Okay, and this, right, almost this will be almost equals to 4 tau. Tau is L by R. We have already computed that. And like, can you write the current expression, mathematical current expression? IO of t, or is equals to IL itself, because that is the output current for this circuit, is simply equals to, initially it was 0 current. Okay, so if initially it was 0 current, it will be something like this: 1 e raised to power minus t upon tau into 1 by r. T equals to infinity, this is going to 0, so this will be simply 1 by r. Okay, so how to write this expression I've explained in my previous marathons, you can go to that. Now what is my VO of t or VL of t? Okay, so simply VO and VL are same itself, so it will be 1, and initially it was 1 volts. Okay, so it will be e raised to power minus t upon tau. Initially if I put t equals to 0, this will be 1, and if I put t equals to infinity, this will be 0. Okay, this is how you do the unit step response. Now let's do the unit impulse response. So impulse response, what will happen? Now again I will copy the circuit. If I can paste this, yeah, I can paste this. So I have this circuit over here, right? And this time, right, my like input is impulse, and obviously the same condition is that my inductor doesn't have any initial flux. So initial flux is 0 again. That is obviously same. How can that change? Initial flux is 0. Then what is happening? Then obviously my initial inductor current will be also 0, as initial flux is 0. Okay, so if initial flux is 0, then what is happening just after t equals to 0? So at t equals to 0, what is happening? At t equals to 0, a impulse voltage is directly getting applied to this inductor, right? Okay, an impulse voltage is directly getting applied to this inductor. So like let me just do one thing. Let me keep this as Vi only. Okay, let me just copy this circuit. It's a bit confused. Let me keep this as Vi volts. Okay, so it has 0 current, so inductor has 0 current, so inductor will be open circuit. If it has 0 current, it means it is open circuit. Here I have 0 current, hence the drop across the resistor is also 0, as 0 times R is 0 itself. So this whole impulse voltage will be across my inductor. So impulse voltage is across my inductor. So what will happen? Inductor will get instantly energized. Why? Because my VL of 0 equals to delta of t. Now VL of 0 is delta of t, so this is equals to L dit by dt. Okay, like you can understand, whenever a impulse, infinite amount of flux, infinite voltage is across a inductor, it will generate flux instantaneously. How? Like mathematically you can prove like this, that it is del L dIL by dt. Okay, and if I integrate on both sides with respect to time, so the integration of del of t is 1, and obviously L I will take on the that side, this will be IL. So inductor gets current instantaneously. So current changes to 1 by L amperes, okay, instantaneously. So this will be not equals to IL of 0 plus. Okay, this will not be equals to IL of 0 plus. So this is the circuit at t equals to 0. So at t equals to 0, this is happening. So previous case, I had a finite voltage across the inductor, so inductor won't change its current instantaneously, as it doesn't generate energy, as it doesn't want to change its energy instantaneously, right? It wants to stay where it is. But here I am forcing it, I am giving it an infinite amount of voltage, so inductor has to change its flux and current. This is at t equals to 0. Okay, so at t equals to 0 plus, how the circuit looks like? At t equals to 0 plus, the circuit is something like this. Okay, so impulse is only for t equals 0. So you have to understand what is impulse signal, all those things, right? You can study from like previous marathon, I have explained what is impulse signal, all those things. So impulse is only present for t equals to 0. After at t equals to 0 plus, it is gone. So del of t becomes 0 at t equals to 0 plus. So obviously this will become short. Okay, this will become short. And here inductor has been instantaneously charged to 1 by L of current, so I can replace it with a current source. Okay, 1 by L, and this is my output voltage, right? This is my output voltage VO. So what will happen? So basically a current will flow. I can write the KVL. So my VO will be simply minus R by L. Like you can apply the KVL, VO will be minus R by L, which is equals to VL also. Okay, now let's go to the intuition. I forgot to talk about the intuition now. So obviously impulse voltage across the inductor, so inductor gets instantly charged to current 1 by L. Then what will happen? This source is gone. Now it is a source free network, so it will be like a source free network. So obviously inductor will discharge its energy through this resistor. As resistor is present in the circuit, so it will discharge its energy, it will lose out energy. So as it is lose out energy, how will it lose out energy? It will lose out like exponentially, right? Because like first order circuit, like the current will be exponential, voltage will be exponential, both of them will be decaying exponentials. The inductor current and inductor voltage, both of them will be decaying exponentials going towards zero, because it will discharge. It is a source free network, so it will go to zero. It will start from here. Inductor voltage current will start from 1 by L. It will go to zero. Okay, plus 1 by L. Inductor voltage at t equals to zero will appear as a impulse. Okay, impulse voltage will be there. Then just at t equals to 0 plus, it will become negative. As it becomes negative, what happens? It becomes minus R by L. Then from minus R by L, it again goes to zero. Okay, goes to 0. It is also reducing, but from the opposite direction, goes to 0. Okay, so that is the intuition. That is how you explain in the interview. So yeah, let's like do this mathematically now. So this is at t equals to 0 plus. Okay, so obviously all of these voltages, right, are at t equals to 0 plus. I will write here 0 plus 0 plus. Okay, so what about infinity? So infinity, this is source free network. So what is happening? My VL is negative. If my VL is negative, that means inductor will what? Discharge, as L di dt is negative, slope is negative. So slope is negative, right? Slope is negative. So it will discharge. It will discharge. Okay. So what will happen? It will discharge, so it will reduce its current. That's why what is happening? Just here some drop is there, right? 1 by L. Then as it is discharging, this current is reducing, this voltage is reducing. So the rate at which it discharges, that is also reducing. Okay, that's why towards the end it reduces very slowly. Okay, that's why the curve is like exponential curve, exponential decaying. So at t equals to infinity, what will happen? Steady state, again my current will be 0. If my current current will be constant, and if current is constant, basically it will go to, the voltage across it will be go to 0. So hence the drop also will be 0. So everything will be 0. So obviously it will reach steady state 0 volts, and VL IO infinity is also 0 amps. Okay, from the inductor I am talking about the output voltage, right? So output voltage and inductor current are both same. Output voltage and inductor voltage are same. Output current and inductor current are same. So let's do the plots. So here it will start from 1 by L. Initially it had 0 current, then it will start from 1 by L. Suddenly it will change, right? Some flux will get injected here. Okay, so it will start from 1 by L amperes, then it will go to 0, and this will be almost 4 tau. And here it will start from where? So initially an impulse has been applied across the output, right? This one is the impulse. Next, what is happening? Next, what is happening? Next, obviously a negative voltage, it reached to minus negative, like a finite negative voltage, which is minus R by L, right? Minus R by L. Next, what is happening? It is going to 0. Okay, it is going to 0. Now there is one significant thing here. What is the significant thing? That significant thing is, this is del of t. Now what does the area of this impulse represent? The area of this impulse represent the flux injected, right? Injected to the inductor at t equals to 0. So I have given it some flux forcefully. I have given it some energy to change its current instantaneously. So how will my equation look like? So inductor current equation, like output current equation, this is simple, right? Exponential. So it will be 1 by L going to 0 minus t upon tau. Now the voltage expression, if you write it like this, that most students, what they make the mistake is minus R by L, then it goes to 0, so minus t upon tau. But you are missing out, there is also impulse signal, right? So you don't forget the impulse signal, because at t equals to 0, some impulse signal is getting applied. So obviously there will be some impulse signal. So this will be del of t. and obviously here I have minus, so this I can delete. So this will be minus r by l e raised to power minus t upon tau del of t minus r by l e raised to power t upon tau, right? So this is how you draw the impulse and step response, okay, intuitively. So now it comes to the poles and zeros. Let us start the poles and zeros. So like, let me take the circuit again. How to find the pole? Either you can find the pole as negative of inverse of time constant, okay, you can find it like that, as it is like first order circuit, okay, or whichever, like you can make the impedance infinite from this node as well, right? From this node, from the input node as well, whichever you want to from the output node as well. If you make the impedance infinite, okay, from this node, you will see how to make this impedance infinite, that I have taught in my realizing poles and zeros intuitively. There I have explained how to make this node infinite, right? This r will be equals to minus sl, so s will be equals to minus r by l, okay, sorry, minus r by l, yeah. So two ways you can do. Either you can do sp equals to minus 1 by magnitude of the time constant, which is minus what is l by r, so it will be r by l. Or you can make the like node infinite impedance as well, so you can short the independent sources. This will be shorted, okay. Then you can make this node here infinite impedance RL, and you're measuring from here, okay, from here you're measuring the impedance from here. If you're measuring from this node, what will happen with respect to ground? So I have to make this infinite impedance, right? So obviously R has to be equals to minus SL. I will not explain this, okay, this I have explained in my realizing poles and zeros intuitively. I will put the link in the comments below. So my SP will be minus R by L. This will be my SP, okay. So what about my zeros? So for zeros, right, you either, for these type of circuits, you either break the link or you either short the output, okay. So if I short the output, then also like the voltage will be zero. Obviously VO over VI will be zero. For this, for voltage, like voltage transfer function, right, voltage gain. And if I break the link, then also current will be zero, so current into impedance will also be zero, okay. So what I am talking about, so you can watch that video, realizing poles and zeros intuitively. There I have explained this, okay. So either you have to break the link. So can I break the link over here? I cannot break the link, right? Break the link between input and output. Can I break the link? Not possible, because there is a raised, which is not a function of frequency, so I cannot break the link. R tending to infinity, not possible, okay, not possible. Now what else? Can I short the output? Can I short the output? Yes, I can short the output at s equals to 0. So s equals to 0, I can make I can short the output. So and still it is still it is finite, right? So obviously when I short this, right, this has to be also finite. So this is finite, okay, this also has to be finite, right? So all these conditions I explained. So this is like Z1 and Z2. So Z1 is finite. So if Z1 is finite, so this is a valid 0, okay. So at SZ equals to 0, we have a valid 0. So 0 at S equals to 0, then it becomes a bit difficult, okay, because I have to compute other things as well. S equals to 0, I cannot compute the DC gain, okay, by putting S equal to 0, because I am getting a 0 at S equal to 0. So obviously, like, the DC gain is 0 itself. That is there is no thing. The DC gain is 0, okay. But I have to find the value of A, right? How do I find the value of A? Like, my transfer function was A by something pole, right? So I have to find the value of A. How do I compute the value of A? So DC gain is 0 anyways. DC gain is 0. Okay, DC gain is 0. So we have to take the help of high frequency gain to find the value of A. What do I mean by the A? So I have 1 0 and 1 pole, right? So it will be something like this. My transfer function VO over VI will be A times I have a 0 at 0, so A times S divided by, I have a pole at minus, where was it, minus R by L, right? So this will be S plus R by L. Okay, or you can write it like this, like in standard format what we should write, 1 plus S L by R, S tau, right? 1 plus S tau. So obviously I have to compute this A, right? A we used to find out with the help of DC gain, but I cannot compute it now. So what do I have to do? I have to take help of the high frequency gain. High frequency gain. So at high frequency, what is happening to the circuit? At high frequency, at very high frequency, this impedance Z2 is going to infinity, right? This is going to open circuit. So if this is open circuit, I can remove this. If I remove this, the current through this will be 0 amps. Okay, as this is open circuit. High frequency, S is going to infinity, SL will be also infinity. So the drop will be 0. So VI and VO will be same. Here the drop is 0. So VI and VO will be same. So VO of S equals to VI of S at very high frequency. So VO by S by VI of S equals to 1, which is equals to A itself, not A, which is equals to what? If I make S tend to infinity, what? Only the coefficients of S will remain. So here A will remain and here L by R will remain. So this will be, just hold on, L by R. Okay, so A will be simply L by R. Okay, A will be L by R. So what will be my final transfer function? This is a circuit at S equals to infinity. What will be my final final circuit? So this is H of S and H of infinity. This is equals to H of infinity, right? H of infinity. My final transfer function H of S will be simply S into L by R divided by 1 plus S L by R. So this will be my solution to this question. So now we can we plot the Bode gain and phase plot for this? So phase plot is not that important, but gain plot is very important. So you have to understand. So all these things, right, I've explained in my previous videos. You can go to my previous transient videos. So what will be the Bode gain plot? So Bode gain plot will be something like this, that this I am getting a pole at R by L, okay, and I'm getting a 0 at 0. So initially my slope will be positive. Okay, so initially my slope will be positive, and initially what is happening is that at high frequency my gain is 1. High frequency my gain is 1, and before that obviously my gain will be something lower than 1. Okay, gain will be something lower than 1. So as this is SL by R and this is 1 plus SL, so numerator is always higher than the, denominator is always higher than the numerator. So it is something lower than 1. So log of something lower than 1 will always yield me something negative. So if I am getting something negative, so I'll start from the lower than the 0 dB axis. So it will start from here. Okay, and at this point at corner frequency L by R, my gain will become 1. Okay, because obviously here my initial slope was plus 20 dB per decade, because initially I had a 0 plus 20 dB per decade. So initially I had a slope as 0, right? Next what I had, I get a pole at R by L, and after that slope becomes 0, because that pole is contributing minus 20 dB per decade and this 0 is contributing plus 20 dB per decade. So after that my slope will be 0. Okay, so slope will be 0 over here, hence it can't change its magnitude anymore. So obviously at infinite frequency I know that I will go to 0 dB because gain will be 1. So obviously it has to reach to 0 dB here, right, at this corner frequency itself. Okay, so this will be R by L. Now let's plot the phase. So phase is a bit different. So if I do if I copy this transfer function, right, let's just copy this transfer function and paste this here and here also. So how will the phase gain look? So I have a 0 at S equals to 0. So this will contribute how much angle? This will always contribute 90 degrees angle, because this doesn't have a real part. Numerator doesn't have a real part. Tan inverse imaginary upon real, L by R upon 0, tan inverse infinity, which means it is always contributing 90 degrees. So it will always contribute 90 degrees no matter what. Okay, so after that what is happening at omega p, my omega p is equals to R by L, right? Omega P equals to R by L. So omega P is equals to R by L, and at R by L, what is happening? R by L basically, this is log of omega. So even though we're writing omega, this is log of omega. You can see my Bode plots videos. There I've explained this very details, like in details. Why do we write log of omega? Why are we writing omega only here? Okay, what does these things mean? So at omega t, I have a pole. Sorry, at omega p, I have a pole which is equals to R by L. So just 10 times before this and 10 times after this, I will have a slope of minus 40 dB per decade. Okay, after that it will die off. So if my omega p is here, let's say here, so 10 times before this, which is omega p by 10, and 10 times after this 10 omega p, I will have a slope of minus 40 dB per decade, 45 degree per decade, then it will drop. Okay, and at t equals to at s equals to infinity, what is happening? My overall, this is also contributing what, 90 degrees minus 90 degrees, this is contributing plus 90 degrees, so overall it will drop down to 0 only. So it will be something like this. Okay, so here obviously it has, like, the slope is what? Slope is minus 45 degree per decade, so obviously it will drop down to 45 degrees at corner frequency omega p. Okay, so one decade means minus 45, so it has dropped one decade, so minus 45. Another decade it will drop another 45. Overall it will drop out to minus 45 degree per decade, and here the slope will be 0 degree per decade, and here also the slope will be 0 degree per decade. So this is basically the complete analysis of the circuit 1. So now let's go to the circuit 2. Okay, so what is this? Is simply the same circuit only, just L and R are interchanged. So it is a LR circuit instead of a RL circuit. So the analysis will be same, so I will go a bit fast this time. So number of energy storing element, independent energy storing element, will just copy this statement if I can. Okay, yeah, number of independent energy storing element will be 1. So all of this will be same, right? Response will be exponential again, right? This simply R and L are interchanged, so obviously time constant will be R L equivalent by R equivalent, which is L by R. So everything will be same, every analysis will be same. But after that, what is happening? Let's go to the intuition. So if I just copy this circuit for unit step, what is happening? For unit step, initially inductor is unenergized, so no flux is there, so current is 0. So now if I apply a voltage, okay, this current is 0, okay, this is in series, so here the output voltage initially will be 0, okay, and a finite voltage has been applied across the inductor. So inductor, a positive finite voltage has been applied, so DIL by dt is positive, so current will try to increase, so current will increase, and as current increases, this voltage drop also increases. So voltage drop increases, so voltage at this node increases, and voltage at this node is fixed, okay, which is 1 volt unit step. So overall voltage across the inductor reduces. So if overall voltage reduces, the rate at which it is charging reduces. So if the rate at which it is charging reduces, so what will happen? It will try to go to 0, right? It will try to go to 0, as DIL by dt will be is still positive, but it is less positive than the previous case. So by the amount which IL was increasing, it will reduce to lower. So as this totally, like IL, like this voltage IL increases further, this voltage will reduce further. So overall what will happen at steady state, this voltage and this voltage will be same, so DIL by dt will be 0, so current will not change anymore and it will reach steady state. Steady state means steady condition, nothing is changing, so current is not changing. As current is not changing, DIL by dt will be 0, hence voltage across this inductor will be 0. If voltage is 0, then VI will be equal to simply VO, and what will be the steady state current, which it will be 1 by R. Okay, so that is how you tell the interviewer if they want to just ask the summary of the circuit, right? So initially inductor has no charge, so I will again copy this whole thing, right? I will just copy this whole thing as I spoke here. So phi of L is 0, all these things are same, okay, not this is unit impulse. Okay, why I'm not able to copy? So now let's understand this with the help of circuits. So obviously if I draw the circuit at t equals to 0 plus, the circuit will look something like this. Okay, let me check if everything is recording. Circuit will look something like this. R, initially current is 0 at t equals to 0 plus I have a 1 volt applied at this end, right? And here the current is 0 amps. So obviously the voltage at this node, right, is simply ground, which is 0 volts. So voltage across the inductor is 1 volt, right? Voltage across the inductor is 1 volt. So 1 volt, which is finite. As it is finite, so IL 0 plus will be equals to IL 0 minus, and as it is greater than 0, so current will increase, right? Current will increase, but the rate at which it increases reduces, right? DIL by dt reduces as current increases, this drop increases, so VL reduces, rate at which it increases reduces. So at steady state, what will happen? If I draw the circuit at steady state, this will be short circuit, okay? This will be R, this will be plus minus 1 volts, okay? So this is plus minus 1 volts at t equals to infinity. And here, right, what is my VO? This time VO is not equals to VL, so my VO will be equals to 0 volts, right? Because initially 0 current is going, and IO is equals to IL itself because it's a series circuit. So this will be equals to my IO also. So my VL of infinity goes to 0 volts. My VO of infinity is what? This is 0 volts, so VO of infinity will be 1 itself, right? It will be 1 itself. So my IO of infinity will be simply 1 by R, okay? Current across the resistor, which is 1 by R. So I can draw the plots. So current is going from 0 to 1 by R, so it will be increasing exponential, which is same as the previous circuit itself, because series circuit is same only, just I have interchanged the L and R, okay? And what about the voltage circuit? Voltage is again same, because I am taking the voltage across a resistor, so current and voltage characteristics will be same, just multiplied by R. Voltage will be multiplied by R with the current, so voltage characteristics will also be same. This will be 1 volts. Initially inductor voltage initially inductor voltage was 1 volt and the resistor voltage was 0 volt. Then at steady state, inductor voltage becomes 0, resistor voltage becomes 1 volt, okay? And this time is photo. Can you write the expression? The expression will be IL, okay, this is not IL and VL, this is IO and VT, right? IO of T and VT of T. So IO of T is equals to 1 by R, 1 minus e raised to power minus t upon tau. Tau is L by R, and V of T is same, just a R multiplied with it, so it will be 1 minus e raised to power minus t upon tau, okay? So let's do the unit impulse response. So initially inductor has no flux, so if inductor has no flux, I will copy the circuit. Can I paste it here? Yeah, okay, no, I cannot, so to copy this from here, like everything will be same, just interchange. So initially it has no flux, so phi of 0 minus is 0, hence I of 0 minus, IL of 0 minus is also 0 amps, right? So if it is 0 amps, so if I just draw the circuit at t equals to 0, because I will have an impulse at t equals to 0, so this will be open circuit, this will be R, this will be R and R. So let's do the intuition approach. So this will be open circuit, so an impulse voltage will be applied across the inductor. So if impulse voltage is applied across the inductor, it will get a flux will get instantly injected to the inductor, hence it will change its current instantaneously, as energy has changed instantaneously, as I have applied a impulse voltage and not a finite voltage. So I am applying a voltage of infinite magnitude, so it will change its current instantaneously, and at what value? It will be integration of 1 by L times that voltage, which is del of t, so it will be 1 by L. So current will go from 0 to 1 by L instantaneously. Then impulse voltage is gone, so it becomes a source free network. Again it will discharge through this resistor, because resistor is a energy dissipating element, so it will discharge through this resistor. And what will happen to my output voltage and output current? Current starts from 1 by L to 0 because 1 by L it goes to 0 at infinity because it is a source free network, and voltage also goes from 1 by L to 0, not 1 by L, R into 1 by L to 0. Okay, but there will also be a impulse which will be applied across the inductor. So here, right, resistor voltage will start from 0, then it will go from go to instantly R by L and go to 0. But inductor voltage is impulse, so this time impulse I am not getting across the resistor. That point is important. So yeah, let's analyze the circuit. There you will understand this better. So obviously my voltage at t equals to 0 across the inductor is what? It is infinity, right? It is infinity. So this is plus minus VL. So VL at t equals to 0 is del of t, which is infinite. Okay, which is infinite, not finite. Not finite. I'll write this over here. Hence my IL 0 plus IL 0 plus equals to not equals to IL 0 minus. As it is not finite, it will instantly change its current. Okay, flux of the inductor will instantly change. Flux inductor will change instantly. Okay, like what will happen at t equals to 0 plus? So what will be the current at t equals to 0 plus? Again, right, the current will be simply L dIL by dt is equals to VL of 0 plus 0, which is del of t. So my IL of 0 plus will be simply 1 by L, right? You can simply integrate. So my circuit will look something like this. 1 by L resistor, and obviously the impulse is gone because at t equals to 0 plus the impulse will be 0. Okay, so this becomes a source free network. So at t equals to infinity, like let me just compute the VO and IO here. VO and IO. So VO of 0 plus will be 1 by L times R, which is R by L, and IO will be simply 1 by L. Okay, and at t equals to infinity, obviously it will reduce its current, right? So current will go to 0 and voltage will also go to 0. At steady state the change in current will be 0, so voltage will also be 0. Hence this will become a source free network. Everything will be 0. VO and IO. Okay, so this will be VO of infinity equals to 0 volts, and IO of infinity will also be 0 amps. Okay, so how will my plots look like? So my plots will look something like this. It will go from 1 by L to 0, and obviously the voltage and current curve will be identical. That's why I don't get an impulse now, because I'm measuring the voltage across a resistor. So current and voltage should be same, like shape should be same, the values will be different dimensionally. So this will start from 1 by L, and this will start from R by L to go to 0, and this will be 4 tau. This will be also 4 tau. So can you write the voltage and current expression? Simple, right? These are simple. It will be simply 1 by L e raised to power minus t upon tau. VO will be R by L e raised to power minus t upon tau. Okay, so now let's comment about the poles and 0. We've done the impulse and step response. Let's comment about the poles and 0. So basically, again, right, poles and 0 will be same, exactly same as here, right? Exactly same as this case. Okay, as this case, right, which we computed here, exactly same. So poles and zeros will be exactly same. Oh, I will just write it anyways. Okay, so like they are same circuit, just R and L interchange. So this one, I think you can do the analysis, but still I will do. Don't worry. So here my circuit is what circuit is this. So poles will be what? Negative of inverse of time constant, or if I am able to make infinite infinite impedance at the output node, so it is minus of L by, not L, R by L, right? So you got the pole. So this is anyways first order circuit. Now what about zeros? Zeros means break the link or short the output. Can I break the link? Yes, I can break the link at s equals to infinity. S equals to infinity, I can break the link, but that's not finite, right? Not finite. So I will write here, can I break the link? By link I mean this between input and output. So if this goes to infinity, obviously no current will go through here, right? So I can break the link, but s equals to infinity, SL, when s goes to infinity, which is not finite. So I don't have a finite zero. I don't have a no finite zero. Okay, so as I don't have a finite zero, so can I short the output? No, it is not a function of frequency. So this is the first thing that I tried. Second thing that I try is shorting the output. This is not a finite frequency. Sorry, my output register, that is Z2, is not a function of frequency. Obviously, we cannot short the output. So I don't have a zero. I only have a pole. So from the DC gain, we can compute the value of A. So what is the DC gain? DC gain is when s equals to 0. So if s is equals to 0, this becomes short circuit. If this becomes short circuit, then my circuit will look something like this. So obviously from here I can directly write my VO will be equals to VI. So VO by VI is equals to 1, which will be equals to my A, okay, which is H of 0. H of 0. So my from here, right, my A like H of S will look something like this. H of S will be A, I don't have a 0, I have a pole at minus R by L, so it will be SL by R. It will be SL by R, okay. So yeah, I have a pole here. So my transfer function will be 1 divided by 1 plus SL by R. Okay, so this will be my transfer function. So now what is happening at s equals to 0, I have a gain of 1, that means 0 dB. Then I don't have a 0, so it will stay at 0 dB. Then just at this corner frequency, my slope will become minus 20 dB per decade of the Bode plot, right? So if I just write the transfer function, h of s equals to 1 by SL by R. So at s equals to 0, like near about very low frequency region, my gain is almost 1. So low frequency region gain is 1. Okay, so that means in dBs it will be 0 dBs. Then at R by L, I have a corner frequency. After that, my slope becomes minus 20 dB per decade. Minus 20 dB per decade. Okay, and it goes on till that. Okay, because like at higher frequency, my gain is 0 and log of 0 is minus infinity. Okay, so let's talk about the phase plot. So obviously again, my h of s is 1 by 1 plus SL by R. So my omega p is again R by L. So 10 times before that and 10 times after that, I will have a slope of minus 45 degree per decade, obviously. But at DC, what is happening? My phase is 0 degrees. Okay, I don't have a 0, so my phase will be 0 at DC. So it will be 0. It will start from 0. Now, if my omega p is here, 10 times omega p, like omega p by 10, and 10 omega p is here. So obviously it will be something like this. 10 times before that, it will start to decay with minus 45 degree per decade up until 10 omega p. Then again the effect of this pole will be gone, so it will again go to 0 dB per decade. So here my initial slope is 0 degree per decade, obviously, and it starts from 0 degree per 0 degree itself. Then here my slope becomes minus 45 degree per decade, because due to a pole in the Bode phase plot, it contributes minus 45 degree per decade. Then again my slope becomes minus like 0 dB per decade, and at this omega p, right, at the corner frequency, my phase will be minus 45 degree. You can compute, right? You can compute the phase. It will be minus 45 degree per decade. Okay. So basically that's it for this circuit. Okay, so what is happening in this circuit? So here also I have a single inductor only, so this will be obviously a first order circuit only. So number of independent energy storing element is 1. Number of independent energy storing element is simply 1. Okay, so as I have only a single inductor itself, so that's pretty easy. So now what will be my time constant now? So like as this is a single pole, obviously response will be exponential, like single pole, hence response will be exponential. Okay, so I have to reduce all this size. Now what is important is the time constant. Can you tell me what will be the time constant? Again, my time constant, right, will be L equivalent upon R equivalent for a first order circuit. So what is L equivalent? So obviously we have to short this short this source, right, energy source. So it will be R1, R2, and it will be L. So L, like I have only a single L, right? So it will be L upon what? R1 parallel with R2. So R equivalent is R1 parallel with R2. That is my R equivalent simply. So now let's come to the step response, right? So if I just copy this circuit, what will this become? So basically initially what I am giving it a step, and obviously inductor has no energy, so zero current. So if I will assume one thing, that R1 is equals to R2 equals to R. So this thing I have to assume. So if I assume this, then what will happen? This inductor has zero current, so this will be open circuited. If this open circuited, here no current will flow. So these two R1 and R2 are in series. So if these two are in series, so I can simply apply a voltage divider as R is equals to R. So here the voltage will be VI by 2, which is 1 by 2. Then what is happening, as this is VI by 1 by 2, so the voltage across the inductor is also same, as they are connected in parallel. So it is something positive voltage, so the current will increase. Okay, as dIL by dt is non-zero, which is also positive, so current will increase. So it will also take some current, it will also try to store some energy. As current is increasing, the current through here will reduce. Okay, the current through here will reduce. If current is through here is reducing, hence the voltage also will reduce, hence the VL also will reduce. So as VL reducing, the rate at which the current it takes, okay, that will also reduce. So at certain point it will reach steady state, and if it reaches steady state, the rate is reducing. As the rate is reducing, it will go to zero sometime. So the rate at which it takes the current is reducing, and it goes to zero. So if it goes to zero, then this is short circuited. As this is short circuited, as the voltage is zero, hence overall this will be also short circuited. So overall what will be the current? Current will be 1 by R itself. So current is 1 by R. Okay, and that is the inductor current. Basically current through here becomes 0. Okay, but I have to compute the current here through inductor and the voltage through inductor, so I will comment about VO and IO only. So that will happen with induction. Okay, so that is what will happen in the circuit. So let's like write this down, let's do the analysis. So initial flux is 0. Okay, so obviously what I will say that initial current IL0 minus is 0 ampere. Now as like IL0 plus will also be 0 ampere also. Why? Because if I just draw the circuit at t equals to 0 plus, okay, this I will just copy and paste. T equals 0 plus, inductor has no energy, so this will open up and all of the current will flow through here itself. So if all of the current flows through here itself, this will be R and R. So my VI will also be 1 volt. So obviously I can compute that VO of 0 plus or VL of 0 plus is simply 1 by 2 volts, right? 1 by 2 volts. So it is 1 by 2 volts. So if it is 1 by 2 volts, that means dIL by dt is it is greater than 0, so dIL by dt is positive, hence IL will increase, but it is finite, right? It is finite, hence IL of 0 minus will be equals to IL of 0 plus. Okay, so this is what it will become. So basically flux will increase, hence the current will also increase. Okay, then at steady state, the rate at which current is increasing reducing, hence the VL of 0 will also go to 0 at steady state. So circuit will become something like this. This will be R, and at steady state this will become short circuited. Okay, so what will be the current and voltage at this node? So basically I still have a 1 volt over here. Okay, so basically this is at t equals to infinity, and this is at t equals to 0 plus. So at t equals to infinity, this is it. So obviously my VL of infinity or VO of infinity equals to 0 volt itself, but is my current 0? No, right? All of the current will not flow through here because this has 0 volts, so this has 0 currents as well. So all of the current will flow through here, which is 1 by R, right? So IL of infinity equals to IO of infinity equals to not 0, I'm sorry, 1 by R current, right? 1 by R amps, because this has gone to 0, so the potential across the resistor is 1, so it is 1 by R. So let's do the plots. Obviously current is going from what? Current initially was 0 through the inductor, then it go into 1 by R current, and it is a first order circuit. Obviously it will be exponential. Okay, and voltage obviously won't be same as current, as this is not resistive, right? So voltage initially was what? Half volts, right? Half volts, because here I had drop, so initial voltage was half volts and initial current was 0, obviously. So voltage was half, it went from 1 by 2 to 0 volts steady state. So this will be 4 tau, this will be 1 by 2, this will be 1 by R, 4 tau. So IO of t equals to 1 by R 1 minus e raised to r minus t upon tau. Okay, and this one will be V, this is not VL, or like they are same right now, but this is mainly VO of t and IO of t I'm plotting. So it will be 1 by 2 e raised to power minus t upon tau. Tau is R by L. So let's do the unit impulse response now. So if I do the unit impulse response, it will be just a bit different. I will just copy this circuit and paste it over here. So obviously again initial flux is obviously 0, so initial current will also be 0, right? IL 0 minus is 0. Now what is happening intuitively? What is happening if I am applying a impulse voltage here? Again it will become open circuit, all of the current will pass through here. What is that current? It is like, it will be like a voltage divider, so it will be del by 2R. Okay, del by 2R again, right? Del by 2R or del of t, it is again a voltage of infinite magnitude. Okay, so which is getting applied to this inductor. So obviously this inductor will change its flux instantaneously, but this time, right, I'm not injecting exactly one flux. This time I'm injecting half flux, because the voltage has been divided between these two resistors, so it will instantly get charged to 1 by 2L current and not 1 by L current. That will be just the difference. Next, again this will get shorted because the voltage source is gone, so this will get shorted, and this inductor is present with two resistors, so again this will become like a source free network, and I can like this inductor will discharge through both of these resistors and it will go to 0. So the current will go from 1 by 2L to 0 amps. Okay, and the voltage, I will have an impulse voltage at t equals to 0, that is delta by 2, area is 1 by 2. Then what will happen? Then suddenly the voltage will become negative as current is reducing, right? As current is reducing, the rate at which the rate of change of current should be negative. That's why the voltage becomes negative, which we will see in the analysis. So voltage becomes negative and it will go to 0. Okay, so yeah, that is what will happen. So at t equals to 0 minus, this is IL of 0 minus is 0 amperes. So let me draw the circuit at t equals to 0 plus, t equals to 0 exactly. So at t equals to 0, this is R, and this is delta of t. So this will become open circuit. So obviously the voltage across the inductor becomes delta t by 2R, right? So VL of 0 equals to delta t by 2, not 2R, so delta t by 2. So obviously, which is not finite. Not finite, hence it will go to what? It will go to it will not be equal. So my IL of 0 minus will not be equals to IL of 0 plus. So it will not be equal. Okay, so it will not be equal, right? If it is not equal, then obviously I have to compute it. What will be it? So it my L DIL by dt is equals to VL of 0 plus, which is VL of 0, which is delta t by 2. So if I integrate my IL of 0 plus, will become 1 by 12. So my circuit, how will it look? Impulse will be gone, right? At t equals 0 plus, impulse will be gone. So voltage will be short circuited 0 volts, and this will be something like this. Current will go something like this, 1 by 12. So 1 by 12, now it will see equal impedance, right? So it will get divided to here it will go, this is at t equals to 0 plus, right? Not equals 0, t equals 0. So here it will go 1 by 4L, but as it is seeing equal impedance, here also it will go 1 by 4L. So what is the drop? The drop is what? It is here plus minus R by 4L, right? So the output voltage is what? This IL0 plus, VL0 plus is what? Minus R by 4L. You can apply simple KVL. Okay, so VL0 plus is minus 1 by minus R by 4L. Okay, so now if we compute at infinity, so what is happening? This is negative, so this is negative, so rate of change of current is negative, so current will reduce. So current is reducing, hence it will go to 0 at steady state, because my my voltage is also reducing, current is reducing, so voltage is also reducing. Voltage will go to 0 as the rate of change of current will go to 0, hence the voltage will also go to 0. It will become source free, hence everything will be 0. Okay, so obviously this is my VO and this is my IO. So as voltage is 0, hence the current through these two resistors is 0, hence the current will through here also will be 0. So VO of infinity is 0 volts and IO of infinity is 0 amps. Okay, so like if you want to plot, right, the IO and VO, so what will happen? IO and VO, if you want to plot, initially my current just instantly changed to 1 by 2L, and then it reduced to 0 amps and 0 amps, and this is 4 tau. And what about my voltage? I saw a impulse voltage at t equals to 0 of area 1 by 2. So this is amount of the flux that has been given to the inductor. Then it suddenly went to negative at t equals to 0 plus, went to minus R by 4L, and then it went to 0. So this will be simply 4 tau. Okay, so can I write the expression of this equation? So IO of t will be 1 by 2L e raised to power minus t upon tau and V of t, you can't forget the impulse, it will be delta t by 2 minus r by 4l e raised to power minus t upon tau. Okay, so this will be my answer to this question. So now, like, let's compute the poles and zeros. So for poles and zeros, this circuit is a bit different. You can compute the poles, okay, by negative of time constant, or you can compute the equivalent resistance as well. I will compute the equivalent resistance here. At this node to make it go to infinity, right? At this node. So this is R1 and R2. Okay, R1 and R2. So I will assume R1 and R2 as R itself. So obviously I have to make infinite impedance. So this impedance is what? R. So R by 2 plus SL has to be 0, or R by 2 has to be equals to minus SL. So how am I doing this? You have to watch my poles and zero videos. So SP equals to minus R by 12, or you can see it is the negative of the time constant whatever we computed there. Okay, so it is parallel, so I have assumed here R equals to R, R1 equals to R2, so it will be minus R by 12. So next, about zeros. So can I break the link? Let me just copy the circuit if I have. Can I break the link? No, right? I cannot break the link. Right? Because this is not a function of frequency. But this is my Z2, right? This is my Z1. This is my Z2. Can I make this short the output? Can I short the output? Yes, it is possible. Okay, at S equals to 0, which is finite. So it will be short, right? I can make this infinity, but that's not the point. I want to make this short the output. I want to short the output. So basically, can I break the link? No. Can I short the output? Yes, at S equals to 0, it is getting 0 and it is finite. So as it is finite, so S equal to 0 is a valid 0, right? We have a 0 at S equal to 0. So my transfer function will look something like that. AS divided by 1 plus, this is what? S12 by R. Okay, so obviously with the help of DC gain, I won't be able to find my A. So DC gain will be 0. Okay, DC gain will be 0. I have to compute the high frequency gain. So what will be my high frequency gain? What will my high frequency gain? So my high frequency gain, if you just observe the circuit, if my S is going to infinity, this will be SL will be infinity. So this will be giving infinite impedance open circuit. So as it is open circuit, as R1 is equals to R2, so simply it will be like a voltage divider, and the voltage here will be VI by 2. So VO will be, VO of S will be equals to VI by 2. So VO over VS, sorry, VO over VI of S equals to 1 by 2. So if I put here S equals to infinity, this is H of infinity, which is what? H of infinity is what? If I put infinity, only the coefficients of S will remain. So this will be A by 2L by R. So A equals to again L by R itself. Okay, A is L by R itself. So my transfer function H of S will be S L by R divided by 1 plus S 2L by R. Okay, so this will be my simple transfer function. Now can we plot the border plot again, right? I can copy the transfer function. Again, the similar reasons. I have a 0 at S equals to 0. So initially my slope will be plus 20 dB per decade. And if I what is happening, this, right? If at very low frequency, this is anyways low and this is very low, so this is something low divided by 1, so this will be very low, right? This will be lower than 1. Okay, this will be lower than 1. As it is lower than 1, it will be starting from negative, right? As my s is going to infinity, what is happening? What is my high frequency gain? My high frequency gain is 1 by 2. So again it is negative, so it will settle to somewhere negative, not 1. Okay, it will not settle to 0 dBs, right? So this time my high frequency gain is half, so log of half is something negative, so it will settle to half. So my Bode plot will look something like this. It will not touch the 0 dB axis, it will touch here, right? It will touch here. This is equals to what? This is equals to minus 20 log of 2, and here I have plus 20 dB per decade due to the 0 at s equals to 0, and again the slope, the pole contributes minus 20 dB per decade, so overall my slope becomes 0 dB per decade after the corner frequency. What is the corner frequency? It is r by 12 basically here, right? If you observe it correctly, omega p is r by 12, that this is my corner frequency. Okay, so this is how your Bode plot will look like. Now let's plot the phase plot. So if I plot the phase plot, I will just paste my transfer function again. So it will be what? Here I have a 0 at s equals to 0, so obviously starting from omega equals to 0, I'm getting a plus 90 degree contribution from due to this 0. So there will be a plus 90 degree contribution due to this 0. Then where is my pole? My pole is at r by 12, so just before 10 omega, that's before this 10 times this pole. Okay, and just add this omega p, and just after this 10 omega p, what will happen? Basically I will get this pole will contribute a slope of minus 45 degree per decade. So my slope will be something like this, and at s equals to infinity, overall phase is 0, because tan inverse 90 minus tan inverse 90 is 0. Okay, both of them, sorry, tan inverse infinity minus tan inverse infinity is 0 itself, right? So both of them are contributing 90 degrees. So here my slope, this like here my slope is 0 degree per decade, here my slope is minus 45 degree per decade, here my slope is 0 degree per decade. So this will be 45 degrees. This will be 45 degrees. So yeah, this is how your Bode phase plot will look like. So the next circuit is D1. So here, right, currently we have two inductors here. So this will be very interesting analysis, so you have to listen to this carefully. So this will be the most interesting analysis out of all of the circuits, right? So first of all, we have to tell about the order of the circuit. So for order of the circuit, you obviously make the independent sources 0, that is, we have a voltage source, we will sort this source, and then we will compute the number of independent energy storing elements. So if I make this voltage source 0, okay, I will just copy this. Okay, if I make this 0, so what do I observe? The voltage across this inductor and voltage across this inductor is same itself, right? Point A and B are same itself. So obviously they are dependent with each other, so they are not independent energy storing elements, they are dependent energy storing elements. So I can write that order of the circuit will be like number of independent energy storing elements will be what? Number of independent energy storing elements will be 1. Okay, so it will be 1. So like that means like voltages are dependent, that means we will have a single pole and response will be exponential. So response will be exponential. So obviously for the first order circuit, the tau, that is time constant, is L equivalent by R equivalent. Okay, so what is L equivalent here? L equivalent, as these two are in parallel, it will be L1 parallel with L2, and we have only one R. So it is R. Okay, so it is R. So like you can compute the L equivalent from itself. That's the, like these two are in parallel, so it will be L1 parallel with L2. Now let's come to the unit step response. So what will happen to the circuit intuitively? So here, let's first understand by intuition. So if I give a unit step over here, what will happen initially? This inductor is initially uncharged. This is also uncharged, unenergized. So the current through both of this, they will try to keep it at 0. So current through this is 0 amperes. Current through this is 0 amperes. So the current through here also will be 0 amperes. Hence the current across the resistor is 0. Hence the voltage drop across the resistor is 0. Hence the voltage across this is also 0. So voltage across this inductor 2, VL2 is 0. So here at this node I have 0 potential, and at this node I have 1 volt potential as unit step has been applied. So overall 1 volt will come across this L1 inductor, right? Total 1 volt will come across this L1 inductor, and they will not get divided. They will not get divided. So you have to take care of that. Now what will happen after this? So which is like a 1 volt is getting applied across this inductor, which is finite. So obviously the current will increase through this inductor. DIL by dt is positive, current will increase. So as current increases, what will happen? Then some current will flow through this resistor. As some current flows through this resistor, this inductor will have some drop. Okay, as this inductor has some drop, so obviously potential at this node will increase. So potential at this node increases, and the potential at the node is still 1 volt. So potential at this node of this inductor overall across this inductor decreases. So potential decreases, hence the rate at which the current was increasing decreases. So obviously current will still increase, but the rate at which it was increasing will decrease. But here, right, as more current is flowing at this node, so this inductor is also taking some current, so its potential is increasing as the current through this resistor is increasing, hence the rate at which it takes the current increases. Now at steady state, what will happen? At steady state, its rate increases and its rate is decreasing, right? At steady state, the voltage across this inductor, as the voltage is decreasing and the voltage is increasing, it will be equal to each other. Okay, why? Because if they have reached steady state, then the rate of change of current and the rate of change of this current is 0. Okay, they have reached steady state, so there won't be any rate of change of current. So if potential is like di by dt is 0, then obviously they will behave like a short circuit. But then what will happen? I have 1 volt, and if this behaves like a short circuit, so the current through the resistor is 0. So these two are in series, and a 1 volt is connected across short circuit of two inductors. Basically the voltages will get divided across the two inductor. So what will happen? The voltage is constant. The voltage will be constant across the inductor. It will not be 0. So for it to reach steady state, it doesn't necessarily mean that the voltage has to be 0. What it means that the rate at which the current was changing for this inductor and the rate at which the current was changing for this inductor, the rate at which for which the current is decreasing for this inductor, and the rate at which current is increasing for this inductor, both of them will be equal at steady state. When they will be equal, basically all of the current will flow through here and it will reach steady state. None of the current will flow through this resistor. Okay, this will go out of the picture. Okay, this will go out of the picture. So this will go out of the picture, but still there will be some constant current flowing through this. I will talk about that. Don't worry. Okay, so here I have L1, here I have L2. Okay, so at steady state, what will happen? The voltages across this will be 1 by 2 and 1 by 2 volts. Okay, as this will provide very low impedance path with respect to this R. Okay, as these two are in parallel, L2 will provide very low impedance path with respect to the R. So R I can ignore for a second. So most of the current will flow through here. Okay, so voltage is constant. As voltage is constant, the current will be what? It will be a ramp current, right? It will be a linear ramp current. Just like linear charging of capacitor, it is like a linear charging of inductor. It's like linear charging of inductor, right? Constant voltage is connected across a inductor, so it will be linearly charged. It will linearly charge, or it will linearly energize. So this is what will happen to the circuit, and I have explained this intuitively, right? But if you have to analyze the circuit, we have to analyze everything, right? We have to start from the scratch. So obviously I will assume that initially inductor has no flux. initially inductor has no flux, right? L1 okay, so phi of zero minus will be obviously zero waivers. Okay, it will be zero. Now as they have no charge, so how will my circuit look? If I copy this, right, and paste this over here, how will my circuit look? So this inductor will be open circuit. That means like this, right? That means my IL 0 minus is 0 amperes. So IL 0 minus is 0 amperes. So here what will happen? This and this will be open circuit obviously, as they are 0. So current through here is 0 amperes. Current through here is 0 amperes. So obviously the current through the resistor will also be 0 amperes. As the current through the resistor is 0 amperes, the drop across this resistor is 0 volts. Okay, drop across the resistor is 0 volts. So what will be the drop across this inductor L2? So VL2 will be 0. Okay, VL2 will be 0. So obviously it will not change this current. VL2 will be 0. Okay, just after this is at t equals to 0 plus. Okay, and what about my VL1? So VL1, I observe this node is at 0 potential and this node is at 1 volt, right? This will be interchanged to 1 volt. Okay, so this is 1 volt. So obviously VL1 is 1 volt, which is positive. Okay, greater than 0, which is finite. As it is finite, what will happen? My IL of zero plus will be equal. It will be 0 both for both IL1 and IL2. Okay, because for anyways like VL2 is 0 anyways, so it will be 0 anyways. But for inductor, as it is finite, it will remain same, but it will increase after this, right? After this it will increase. Okay, so let me just take this on the right hand side. Okay, so this is what will happen at t equals to 0 plus. Now as this is a first order circuit anyways, everything will be exponential, but at t equals to infinity, what will happen? T equals to infinity, if we carefully observe, right, if you carefully observe, t equals to infinity will be something like this. If I draw the circuit, and what will happen? This will provide very low impedance and this will also provide very low impedance, right? This will also provide very low impedance with respect to this, okay, at steady state, because at steady state the drop across this will be almost low, right, almost negligible. So now as if I directly replace this with short circuit, right, as at steady state we assume that the voltages rate of change of current will be 0, so hence the voltage will be 0 because they will reach steady state. This will be 0, this will be 0. So and here, right, I have 1 volt connected across it. So if I draw it like this, what will happen? Total 1 volt is connected across total short circuit. Okay, it doesn't work like that. There are inductors over here. So and the values of inductor, what I have assumed is assume, like I should have told you earlier, assume for easier analysis L1 equals to L2 equals to L. Okay, assume this. So obviously this, right, I can replace with current source which have very low impedance, right, which will provide very low impedance. So I can draw my circuit like this. This will be current source. This will be current source. this will be IL2, this will be IL1, and obviously I have 1 volt connected across this, right? Now as they are providing very low impedance path, so the potential across this will be again like this. Resistance I can ignore, the potential across this will be 1 by 2, and the potential across this will also be 1 by 2 volts. Okay, so what will happen over here, this is the circuit at t equals to infinity, right? So obviously my voltage across the inductor VL1 of infinity is 1 by 2. So what will be my current expression? What will be my IL? My IL will be basically, if I just write it like this, that L1 dIL1 by dt equals to my VL, right? So I have to simply integrate it. So IL1 will be 1 by L1, and which is L, integration of 1 by 2 dt. So it will be t by 2L. Okay, similarly IL2 also will be same, IL2 will be t by 2L. Okay, so it will increase linearly. But what about my R? What is the current through here? What is the current through here? The current through here is what? The potential at this two nodes is what? Half volts. So current through here will be simply 1 by 2R. Okay, 1 by 2R. So my VO infinity is 1 by 2 volts, and IO infinity is stable only. It is 1 by 2R amps. Okay, as it is across a resistor. But current, right? Current is different. Current is interesting. Current is different. Current is just simply this ramp function, which is the inductor current. Okay, but we are not plotting the inductor current. We are just plotting this IO and VO, right? And initially, what was IO? If I just mentioned, like VL2 is VO itself, so VL2 is 0. So my VO is also 0, and my IL this, if VO is 0, obviously the current through the resistor will also be 0. So I can write IO of 0 plus will also be 0 amps. Okay, so now we can plot it, right? This is IO and VO. So initially it was 0, then it went to 1 by 2R. Initially it was 0, then it went to 1 by 2. Okay, pretty much same thing. Okay, but the next circuit for which we will plot, that will be very, very interesting for us. So this is 1 by 2, 1 by 2R. This will be 4 tau. This will be 4 tau. And what will be the expression? The expression of IO of t will be 1 by 2R 1 minus e raised to power minus t upon tau, and VO of t will be 1 by 2 minus e raised to power minus t upon tau. Okay, so this will be my IO and VO. Now let's do the unit impulse response. What will be the unit impulse response? So if I do the unit impulse response, so let us first intuitively understand what will happen. This one is simpler. Okay, so obviously if I apply impulse, this will be open circuit, this will be open circuit. Again the same thing will happen, as this is open circuit, current through here is 0, so current through this resistor is 0, so drop across this inductor is 0. So it is finite drop across this inductor, which is 0 volt. But this node is 0, but this node is impulse voltage. So the whole impulse voltage is applied across this inductor. So this inductor gets instantaneously energized to 1 by L of current. So this inductor will go to 1 by L of current. Okay, then this 1 by L of current will discharge through this inductor and this resistor also. So this inductor will store some of it, some energy, and then again it will also discharge through the resistor. Okay, as this this has been charged, so some current will flow through this inductor and this resistor, and slowly all will go to 0. The voltage, current, everything will go to 0 itself. Okay, so it will start from, like, if I have 1 by L current over here, then this will again try to get to its steady state, that is 0 currents only at the starting. Obviously this will be 0 amps only, so this whole 1 by L of current will flow through this resistor, which will provide a drop of R by L. So initial voltage R by L, it will go to 0. initial current 1 by L, it will go to 0. Okay, as this will be again open circuit. Okay, so yeah, that is how it will work out. So now if I just do the same analysis, right? If I just do the same analysis, if I just copy these things, what will change? I will just say what will change, right? What is happening? Why is this not working? Okay, so obviously this time, right, initially flux will be 0, but the problem is this time it will not be equals to IL1, not be equals to IL1. Why? Because the voltage that is been applied across the L1 inductor is delta of T, right, delta of T, which is obviously positive, but the problem is it is infinite, right, not finite, not finite. As it is not finite, it will not be equals to it. Okay, and my IL2 will be still equal, which will be equals to 0 itself, right? IL2 will be equals to 0 as it is finite. I can observe VL1, VL2 will be still 0 because obviously this has been open circuited, and here I have an impulse voltage. Here I have impulse voltage, and this has been these two have open circuited. Current through this is 0, so 0 volt across this inductor. So only this inductor will have the whole, will have to absorb the whole power, right, whole energy of this source impulse source, right? So this inductor will get charged to what? This inductor as my VL1 of, this is not at 0 plus, this is at 0, right? This is not at 0 plus, this is at T equals to 0. T equals to 0. So because at T equals to 0 plus, impulse will be gone. So my VL of 0 is equals to L1 DIL of 0 by dt. So VL of 0 is what? VL of 0 is impulse. So if I integrate, this will be 1 by L integration of delta of T, which is IL of 0 plus, right? IL of 0 plus. So IL of 0 plus will be what? IL, this is IL1 of 0 plus, right? IL1 of 0 plus is 1 by L amps. Okay, and IL2 0 plus is 0, is that we have already established. So if I just draw the circuit again, this will be at T equals to 0 plus, impulse will be gone because it is only present at T equals to 0. It will become short circuit, and this will be what? This will be again, L2 will be again 0 amperes, right? Because it is still open circuit, but this I will replace, L1 I will replace with a current source. So L1 has been replaced with a current source. So this will be what? This will be simply 1 by L of current. So this has 0 amps of current, so whole current will flow through this resistor. Okay, whole current will flow through this resistor. So obviously my this time, right? Okay, here my IO is what? My VO plus, VO 0 plus, and sorry, not VO 0, VO 0 and IO 0, VO 0 and IO 0, VO 0 and IO 0 equals to 0 amps and 0 volts. So this is 0. So what about now? What about now? This circuit is at T equals to 0 plus. What about now? Now what is happening is my IL 0 plus is this, which is equals to my IO 0 plus as well, which is 1 by L, and obviously my voltage will be just the R multiplication of this, right? So VO 0 plus is R by L, and which is equals to my VL2 0 plus as well, which is positive. Hence this current, like this will also get energized due to this inductor. So this will get energized due to this inductor. Now what will happen at steady state? So at steady state, this is like a source free network. So you will think that, okay, this is like a source free network, so all of the energy will get dissipated through this R, which is a good thinking, right? So basically what is happening after this? A positive voltage is getting developed across this. So it is also taking some current, okay? And as it is taking more current, what will happen? Like it is taking some current, and here then the voltage is again getting reduced because this is taking more current, right? As the rate at which current is increasing, so rate at which it is taking, okay, so di by dt is positive for this because this voltage is positive. So di by dt is positive, so this is sucking in more current. Okay, this is sucking in more current, that means the current here will be lower because anyways this is also de-energizing, right? Because this has stored some energy, now it is de-energizing, so it will de-energize. Okay, so this will de-energize through this inductor and this resistor. So current through this is reducing and this is taking more current, so current through this also will be reducing. So current through this will be reducing, so the rate at which it takes the current, the rate at which the current was increasing will reduce because the voltage across it will be reducing, so dIL by dt will be reducing. Okay, at some point what will happen is that what the current through this is reducing, so and the voltage across this also is reducing. Okay, and the voltage across this also is reducing. What is the voltage across this? Currently the voltage across this is what? The voltage across this is minus R by L. You compute, it will be minus R by L. So it is negative, so obviously it is discharging and it is going towards 0. Voltage is going towards, from minus it is going towards minus R by L, it is going towards 0, and voltage of this, it is going from plus R by L to 0. Now what will happen at steady state? The rate at which the current was decreasing for this case and the rate at which the current was increasing will become same. That is it will become 0. It will become 0. Okay, so the voltage across this will be 0, so current across this will be 0. Okay, but it may so happen that it has 0 voltage, but it can still supply some current. Okay, whatever current it supplies, all of it goes through here, all of it goes through here, and none of it goes through here. That means 0 amperes of current, 0 volts, and everything is satisfying. Everything is satisfying. Now how will you satisfy the equation? How will you satisfy the equation? Basically you will use the flux conservation law. So whatever flux we had, right, that flux went on to this and few of it got wasted in here, right? So you write the flux conservation equation. So L1 into I1 IL1 equals to L2 into IL2 plus L1 into IL1. Just hold on a second, I have to write this infinity, and this will be also infinity. I told you if I just draw the circuit here at t equals to infinity, what will happen? Let me replace these inductors with current sources. The voltage can be 0, right? Across the current source the voltage can be 0. So if I replace this with current sources, this is IL1 infinity so this will be, just hold on, this will be IL2. If I have enough space, I don't have actually, hold on, infinity. Okay, you won't be able to understand this, right? So I'll write it even more. And through here, right, through here the current is 0 ampere. So obviously IL1 infinity equals to IL2 infinity. So IL2 infinity and IL1 infinity are equal, and this is what? This is 1 by L, the initial current, right? This is not infinity, this is 0 plus. Okay, so obviously L1 is L itself into 1 by L. IL1 is 1 by L equals to L2 is L itself into IL plus L into IL. We are just applying the flux conservation law, right? Flux is Li. So that is what we are applying. This is IL. So this is 1. This will be 2 L IL. So my IL of infinity will be 1 by 12. Okay, so whatever current reduced, it reduced to 1 by 12, and then it went up over here, right? Everything went over here as the current through this inductor was increasing. It was 0 initially, it was increasing because the potential across this inductor is positive. So dIL by dt is positive, so current will obviously increase. So if current increases, then it will reach steady state, right? The current through this is increasing, current through this is reducing. At some stage the currents will be equal between these two inductors, and at that stage the current across this resistor will be 0, hence the potential across this resistor will be 0, which will make the voltage across the inductor also 0. And if the voltage across the inductor is 0, so voltage across this is also 0, because this impulse is obviously not there, because it is only present at t equals to 0. After that it will be gone. Okay, after that it will be totally gone. So the potential across this will be 0, potential across this will be 0. Both of the inductors have reached steady state. There will be no change of current. So steady state means no change of current for inductors. Steady state of capacitor means no change of voltage for capacitors, right? dVc by dt equals to 0 and dIL by dt equals to 0. Okay, so that is the case. We cannot simply replace these by short circuit. Okay, we cannot, because across the currents is also the potential can be 0. Okay, potential can be 0. But okay, this is fine. IL is this, but what about IO? IO is our simple thing, right? As voltage is 0, obviously IO infinity will be 0 itself, and as like it is across the resistor, so VO of infinity will also be 0 volts. Okay, so like this will IO will be simple only. Initially IO was what? IO was some initial current which was 1 by L, then from 1 by L it went to 0. Okay, pretty simple curve. 1 by L it went to 0, and VO it went from R by L to 0. This is photo, this is photo. Okay, this photo, this photo, this is IO of t 1 by L e raised to power minus t upon tau. Okay, and VO of t will be R by L e raised to power minus t upon tau. Let us plot the voltage and currents of the inductors also. So this I will copy. So like what will be V? Okay, I will draw 3 plots, that is VL. Let's do for it both of them. So VL2 and IL2. What is VL2 and IL2? So initially VL2 was what? 0 volts. Okay, initially it was 0 volts. Then it became like some positive suddenly to R by L. Okay, and then it went to 0 again. So the curve will be exactly same. Okay, as it is across the resistor itself, so curve will be same. There won't be any change. Okay, the equation also will be same. So I'll just copy this. VL2. Now what about the current? The current is very interesting. So initially the current across this inductor was what? 0 amperes. Initially the current across this inductor was 0 amperes. Here we saw, right, this was 0 amperes. So this is 0 amperes, and then it increased to what? It increased to 1 by 12. Okay, both of them will be equal. It increased to 1 by 12. So this time, right, this equation will be a bit different. This will be something like this. One by 12, and the equation will be 1 by 12 and 1 minus e raised to power t upon tau. So this will be the equation for the current. Okay, Okay, I made a mistake. I shouldn't have done this. Let me copy this whole thing. Let me do back. Okay, we'll just delete this and paste this. Okay, this will be IL2. What about IL1? What about IL1? So if I again copy this, right, and plot the IL1, IL1 and VL1. So what is happening to VL1? So VL1 initially, right, it got across the impulse voltage, it took an impulse. Then what was the voltage? The voltage here was simply minus R by L, right? Whatever the potential here, it is a negative of this, because these three are simply in parallel. But as VL1, the notation of VL1 is like this, so obviously it will be minus R by L, right? So it is minus R by L. So a impulse is happening across it. Let me just delete all this. Impulse happens across it, okay, of area 1. Then it goes to minus R by L. Then it goes to 0 itself. And what about the current? Current is, it got instantaneously charged to 1 by L of current, right? It got instantaneously charged to 1 by L of current. Then it went to not 0, it went to 1 by 2L. That is the most important part over here. One by 12. Okay, so what will be the equation? So at t equals to infinity, this will be 1 by 2L itself, fine. But t equals to 0, this has to be 1 by L as well. So this will become plus instead of minus. And here this will be minus plus delta of t. Okay, and this will be VL1, this will not be IO. IL1, L1, this will be IL2. Okay, so this will be the plots of inductor current voltage of all the inductors, right? So this analysis is very important. If you couldn't understand, you have to go and repeat it again. Okay, this is very, very important analysis. So what about the poles and inductors? Again, it is simple, right? So for poles, what will do? First order circuit, right? Poles will be simply negative of inverse of magnitude of time constant. So negative of L by 2R. So L by 2R. So it will become R here, and it will be 2. Okay, it will be 2. Or what you can do, or make 0 admittance, okay. How can you make 0 admittance? So you observe, okay, either make infinite impedance through the output node or make 0 admittance. Infinite impedance and 0 admittance are saying the same thing itself, right? Admittance is inverse of impedance. So what I can observe, here I have L, here I have L, and here I have R. So whenever things are in parallel, so I will take help of admittance, and whenever things are in series, I will take help of impedance, right? So through this node, okay, through this node. So through this node I will make 0 admittance. So what is the admittance of this? It is 1 by SL, 1 by SL plus 1 by SL plus 1 by R. This should be equals to 0. So obviously from this equation my SP will be minus 2R by L. Okay, my SP will be minus 2R by L. Okay, so just hold on, have I made everything correct? 1 by SL, 2 SL, sorry, this, yeah, everything is correct. This will be 2 by SL, and yeah, it will be 2R by SL. Okay, so this will be my pole. What about my location of zeros? So for zeros, right, I have to copy and paste the circuit again. Okay, not this. If I just have the circuit here, yeah, I can have the circuit here, right? For zeros, what is happening? For zeros, basically, I either have to break the link, okay, or short the output. Can I break the link? right? I can only break the link at s equals to infinity, because L1 will go to like high impedance only when the s is infinity, right? And which is not a finite zero. S tending to infinity, which is not a finite zero, which is not a finite zero. Okay, so it is not a finite zero. Now can I short the output? Can I short the output? So can I short it? If I make this s equal to 0, yeah, it will get shorted, right? But the problem is this will also get shorted. So z1 will also be short. So s equals to 0, z2 is 0, right? That is fine. But z1 is also 0. That is again a bad thing for me. Okay, both z1 and z2 cannot simultaneously go to 0. Okay, so obviously I don't have a 0. So my transfer function will look like this: h of s equals to a by single pone only s l by 2r plus 1. Okay, so like what will be d secant? So d secant will be this only. When s is 0, how is my circuit looking? When s is 0, so let me just copy the previous one. So this will be short circuit, this will be short circuit, and this R will go away, right? Because this inductor will provide low impedance path. So as this inductor provides low impedance path, this provides low impedance path, this provides low impedance path, L and L. So obviously voltage will get divided, right? Voltage will get divided. That is, my VO will be VI into L by L plus L. So VO by VI will be 1 by 2. Okay, V of S by VI of S will be 1 by 2. So obviously my A is equals to 1 by 2. So my transfer function H of S will be 1 by 2, 1 by 2 S L by SL by 2R. Okay, SL by 2R. So this will be my transfer function. So now like what I can do, I can simply plot the Bode gain and phase plot. So what will be the Bode gain plot? It is simple function, right? So we can simply plot the Bode gain plot. So obviously s equals to 0, it is starting from half. So log of half will be something negative. So it will start from below 0 dB axis. So it will start from here. Okay, then I will encounter a pole at what? Omega p equals to what? Corner frequency is what? Corner frequency is 2R by L. So encounter a pole which will make the slope minus 20 dB per decade, and it will remain like that. So obviously at s equals to infinity, my gain is 0. So log of 0 is minus infinity. This is omega p and this is minus 20 log of 2. Okay, and here the slope is minus 20 dB per decade. Okay, what about the next thing? What about the angle? So angle will be same again, right? So obviously initially angle is what? Initial angle is 0. Okay, as at s equals to 0, this is only half, so it is 0 angle. Then what is my corner frequency? Corner frequency is 2R by L. 10 times before 2R by L, I will get a slope of minus 45 degree per decade up until 10 times omega p, 10 times the corner frequency. Then the slope, the effect of pole will go away, which will make it 0. So it will look something like this. Omega p by 10 this will be 10 times omega p. And what will be this angle? Can you tell me what will be this? This angle will be minus 45 degrees and this angle will be 90, because tan inverse of minus infinity, tan inverse of infinity is 90 and it is in negative, so it will be minus 90, and this slope will be minus 45 degree per decade. The slope will be minus 45 degree per decade. Okay, so this is about this circuit, complete analysis of this circuit. If you couldn't understand, you have to replay it again, right? Rewind it again. Now let's solve this circuit. This circuit is almost similar, just the RL structure has been like swapped. Okay, RL circuit has been swapped. So obviously we are computing the current across this inductor now, which we just computed there also. Okay, this is just the same thing only, just the same thing. So again, if you are computing number of independent energy storage elements, if I short this, right, what will happen? It will be the two inductors will be in parallel again. If I short this, the two inductors will be in parallel again. Just hold on a second. Let me check if this is recording. Just let me drink a bit of water. So number of independent elements I can observe, right? This node and this node, they are same. Obviously there are two inductors between these two nodes and a resistor. So number of independent energy storing elements is one only. I can copy if I have. Okay, I don't have that. I have to go way back, so I will write here number of independent energy storing elements is equals to 1. Okay, number of independent energy storing elements equals to 1, voltage same. So it will be single pole as it is single pole, response will be again exponential. Okay, so like what will be tau for a first order circuit? What will be tau for a first order circuit? L equivalent of R equivalent. So in this case again the two L's are in parallel, so it will be L by 2R. The two inductors in parallel, right? Inductors are parallel, so it will be L by 2R. So let's come to the unit step and impulse response. So for the unit step response, again it will be similar analysis only. I am talking about the induction approach. So again 1 volt is here, so this inductor will provide, like this inductor will not allow any current as initial flux is 0. This inductor will also not allow any current, so current through this resistor is 0. So overall voltage across these two is 0. So this has some finite voltage which is 0, okay, and which is also 0, so current won't change through this inductor. But here what will happen, it overall, like this drop is 0, so here overall 1 volt will come across this inductor, as 1 volt is across this inductor. So the rate at which the current, like the DIL dt is positive, so the current will increase through this inductor, so it will charge, it will energize. Now as current is increasing through this inductor, there will be some drop across the resistor because current has to flow through this path. The current through this is 0, hence the whole current will flow through here, and if the whole current flows through here, there will be some drop. If there is some drop, this inductor will also get like some voltage, and this inductor will get some voltage, hence again it will also stuck in some current, and as it takes some current, the current here through here will also reduce. As the drop through this resistor increases, the drop across this will reduce, so the rate at which the current was increasing, it will reduce. Okay, so the rate at which the current was increasing, it will go to 0 at certain stage. When will it go to 0? When this also the rate, this rate is increasing, and this rate is reducing, right? The voltage across it is reducing from positive, the voltage across it is increasing, okay, from 0. At certain stage both of them will sync, and the DIL by dt of both of these will be same. So whatever rate this is taking voltage, this voltage will also be same, which is when so VL1 will be equals to VL2. So if VL1 equals to VL2, that means 1 volt, this 1 volt, if I apply KVL, minus VI plus VL1 plus VL2 equal to 0. So VL1 plus VL2 equals to VI, and I am saying the rate will become same. If the rate becomes same, so VL1 equals to VL2 equals to VL, so 2VL equals to VI, so VL will be equals to 1 by 2 into VI, so it will be 1 by 2 itself. So when the VL reaches 1 by 2, so rate will become same, okay, and they will reach steady state. It won't change anymore, the voltage won't change anymore across the inductor, it will be same, okay. So voltage will be constant, so they will pull in some ramp current, and then that's the steady state, right? As the voltage doesn't change anymore after that. But here, right, as the voltage is half, so through here there will be some half amps of current which will also flow through here. Okay, which will also flow through here, and if I differentiate that, that will be 0 itself. So I will talk about that later. So that if I differentiate, that will be 0, and voltage will be like steady state voltage will be half, and initial voltage was 0, so it will be exponential 0 to half for voltage waveform. For current waveform it will be 0. Okay, and then for a certain stage it will be exponential, and then it will be ramp. Okay, it will be ramp. So we'll solve that, and then we'll see. So like you might say, sir, but the response must be exponential, right? Response must be exponential. Yes, response must be exponential, but linear charging does happen, right? Linear charging does happen through capacitors as well and inductors as well if the voltage is constant across it. So response is exponential. Yes, the voltage response is exponential. Okay, but the voltage is going to constant at some certain value, right? It is not going to 0. Okay, voltage response is exponential, but it is not going to 0. Hence, the current will always keep on increasing. So that is what the analysis is. So what we can do, again I can say, initially inductor has no flux. So as it has no flux, that is my psi of 0 minus equals to 0. So if psi of 0 minus equals to 0, so I can say that my IL1 of 0 minus equals to IL2 of 0 minus equals to 0 amperes. Okay, 0 amperes. So my VL, what will my VL do? So like now let us compute, right? Let us compute. After this, let us draw the circuit. So if I draw the circuit, if I just copy this, just hold on a second. Okay, so this is the circuit, right? So at t equals to 0 plus, t equals to 0 plus, what will happen? T equals to 0 plus, this will be open circuit, this will be open circuit. So this is open circuit. Okay, so current through here is 0 amperes, and current through here is also 0 amperes. So this drop will be 0 volts. Okay, so overall the drop will be across this, right? Overall the drop will be across plus minus 1 volts, as I have applied plus minus plus minus 1 volts, right? So obviously what will happen? So the VL2 equals to 1 volts, VL2 of 0 plus equals to 1 volts, which is greater than 0 and which is also finite, right? Which is also finite. Okay, hence it will be equals to this, and obviously my VL1 of 0 plus is 0 itself, so which is also finite. Okay, which is also finite. So obviously it will be equals to my IL1 of 0 plus and equals to my IL2 of 0 plus. Both of them are equal as voltages are finite. And t equals to infinity, what is happening? T equals to infinity, what is happening here is that this is 1 volts. Okay, so let me just write the output currents and voltage. So VL2 of 0 plus is basically equals to my VO of 0 plus, right? And IO of 0 plus is what? IO of 0 plus is 0 itself, right? IO of 0 plus is 0 itself. Okay, because current won't change, right? This is basically, okay, I should write here itself, like this is basically my IO of 0 plus, IL2 of 0 plus. So that is equal to 0 itself. So now at steady state, what will happen? At steady state, if I just draw the circuit, this will be 1 volt, and here I have resistor, and this will be replaced with a current source. which will have a constant voltage, which will not be zero this time, okay, because it will have some steady state current with it, because it is always getting energized by the source. Okay, I told you already, as this both of the inductors will provide very low impedance path, the resistor I can ignore, and then I am observing that the voltages across these two inductors are equal, which is half volts and half volts. So as it is half volts, it is constant, hence it will get some ramp current. Okay, it will get some ramp current, right? It will be linearly charging. So this will be IL1, this will be IL2. Okay, and here I will have potential plus minus half volts. Here I have potential of plus minus half volts. Okay, and this is at t equals to infinity. Okay, these are t equals to infinity. So obviously my VL1 of infinity equals to VL2 of infinity, which we already have established, equals to 1 by 2. Okay, which is same. So my IL1 of infinity will be what? If I integrate this, okay, with respect to dt, it will be 1 by 2L, and I also have here time, right? And which is same as my IL2 as well. Okay, which is same as my IL2 as well, t by 2L, right? So both of them are same voltage, so same current. Is it same really? Is it same? No, right? It isn't same. Why? Because here what is happening? Here there is some 1 by 2 amps of 1 by 2 R current is also flowing through here, and here t by 2L current is flowing. Now through here there will be t by 2L current flowing plus 1 by 2R. Now if you differentiate this, right, you will again get the same half voltage itself. Okay, it won't change. So this 1 by 2R doesn't matter. So in this case, right, here I was computing this current, right? Okay, I may have made a mistake over here. Okay, slight mistake I have made, that is this, right? Let me just check IL1. This is okay, not the impulse, this is a step. Okay, for the step response I haven't even written the current, right, IL2, so that's fine. So I got saved over there. So I just plotted the VO and IO, okay, which was the most simpler one. And here, right, it is IL2 won't be okay, just hold on. Yeah, IL1 won't be this, right? IL1 won't be this, because IL1 will be IL2 plus IO, and IO is 1 by 2R, so this will be plus. So there is some mistake in my end. This will be plus 1 by 2R. Okay, so there is some, always we get some constant, right? We get some constant while integrating, and this is that constant. This is that constant. Okay, so it will be t by 2L plus 1 by 2R, not simply this t by 2L only, because if I differentiate this, I will again get back to 1 by 2 volts. Okay, I will again get back to 1 by 2 volts. But if I integrate, there can be a constant, right? And this is the constant of integration. Okay, I hope you got the point. So yeah, that, like, we also make mistakes, so you have to be careful about that. So now here if I get back, okay, my IL2 will be t by 2L plus 1 by 2R, and initially it was obviously 0. Okay, and then it become this. So how will my waveform look like? So my waveform, right, here this is the slope, okay, of straight line. This is actually IO and VO. So initially it was 0. Okay, then this is the current. Okay, so it will be like, initially it will be somewhat exponential. Then it will be always above this line, right? Above, shifted up by this line. Why? Because this line is what? This line is simply t by 2L line. Okay, t by 2L line. So initially it will charge slowly. Then what will happen? It will be always above this line, and it will be parallel to this line, right? Parallel to this line. Okay, so here, right, the slope here will become, like, I'm not drawing exact, I'm just drawing intuitively, so you can comment down below the exact plot, right? If we compute it with Laplace or something. I'm not doing the Laplace transform here, just drawing the rough plot. So rough plot, this will be, the slope will be here again t by 2l, right? Slope will be t by 2. So obviously it will be parallel with this. It will be parallel with this, right? So this will be the curve for IO. And what about the VL? So initial voltage, what about the VO? Initial voltage was what? Initial voltage what was 1 volts, then it went to what? 1 by 2 volts. Okay, from 1 to it goes to 1 by 2, not 0, not 0. So it goes from 1 to 1 by 2. 1 volts to 1 by 2 volts. So what will be my voltage expression? So voltage expression will be simply this is going from 1 volt plus initially, okay, finally it is going to half. So this will be 1 by 2 plus 1 minus 1 by 2 e raised to power minus t upon tau. So this will be 1 by 2 1 plus minus e raised to power t upon tau. What about current? What about the current? So current, right? So I can divide it in two components. One is this RAM component and one is this 1 by 2R. So for 1 by 2R, it is going from 0 to 1 by 2R. Okay, so I can write it like this as superposition IO of t is 1 by 2R into 1 minus e raised to power minus t upon tau. This is one component. Okay, another component is this, right? This RAM component. So this RAM component is basically, I can simply add with this, right? T by 2L. I can simply add with this. So okay, if I want to write this in terms of tau, if I want to take this L common, 1 by 2L common. So if I want to take this 1 by 2L common, right? So this will be if I take 1 by 2L common, this will be 2 tau. Okay, so anyways, okay, this will be the expression, right? You can compute at t equals to 0. This is 0 and this is also 0. At t equals to infinity, this is 1 by 2R and this is t by 2L, right? So this will be my basically curve, right? This will be my basically curve. Okay, so but if I differentiate this, this won't be exactly equals to, okay, at t equals to infinity, this will be almost negligible. This will be almost negligible. So this will go away. And now if I differentiate, this will be 0 and this will be t by 2L only. Okay, so this will be 1 by 2L only. So at t equals to infinity, there will be some like slope due to this, but this will be negligible. T equals to infinity, this is almost equals to 0. Okay, that's why this is simply a constant term which is 1 by 2R. Okay, so yeah, that is what will happen. Now let's talk about the unit impulse response. So if I talk about the unit impulse response, what will happen? So for the unit impulse response, basically I will give a impulse over here. Again, this will take 0 current, this will take 0 current, so this will have 0 current, so drop will be 0, so whole impulse will come across this. So this inductor will get instantaneously charged to 1 by L current. As this is 1 by L current, then this will again go away, so this will become short circuit. So this 1 by L current will be divided into this inductor and this range, right? So obviously it will lose some energy, but what will happen, the voltage across it is becoming positive. So this inductor will try to increase its current, and this inductor is anyways reducing its current because the voltage across it will be negative. You can check. So if the voltage is negative, this is reducing, this is increasing, the rate at certain point will become same. That is when the voltages across them will be 0 and the current won't change anymore. If the current won't change anymore, this will become short circuit and the current across this resistor will be 0, but there will be some current that is flowing through this inductor whole loop, right? That will flow through this loop that we just established in the previous case. Okay, so there will be flux conservation between these two inductors. Okay, so yeah, that will happen and the currents will be equal and they will be equals to 1 by 2L simply. From 1 by L it will go to 1 by 2L and then it will remain at steady state. So voltage will go to 0 from impulse, then it will instantly get charged to 1 by 2L and the voltage across it at t equals to 0 plus will be what? Minus R by L. Okay, minus R by L, and from minus R by L it will go to 0. Okay, and current will go from 1 by L to 1 by 2L. Okay, that is what exactly will happen over here. So again, if you do the analysis, initial flux, initial like phi of 0 minus equals to 0. Okay, so IL1 of 0 minus equals to IL2 of 0 minus equals to 0 amperes. So if I draw the circuit now, if I just draw the circuit with the impulse applied across it, with the impulse applied across the circuit, plus minus delta of t, and obviously this has become open circuit, this has become open circuit. So current through this is 0 amperes, current through this will be 0 amperes. So current through this resistor will also be 0 amperes. So drop across this resistor will be 0. So overall drop will come across this inductor only. That is del of t, right? So this drop is del of t. So what will happen? Basically, I can say this inductor VL to 0 plus, not 0 0, is this is at t equals to 0, equals to delta of t. Okay, equals to delta of t. So my current will instantaneously change. So this is not finite, it will instantaneously change. So here this will not be equals to my IL. So this is IL2, actually IL2 0 plus. Okay, IL2 0 plus will be something different. But as VL1 0 is 0 volts, so it is finite. As it is finite, it will be equals to IL of 0 minus. Okay, IL of 0 minus. So this will be the case. So obviously if I draw at t equals to 0 plus, obviously my inductor IL, what will be IL2? IL2 will be simply 1 by L integration of delta of t dt. So it will be 1 by L of current, right? It will be 1 by L of current. So this is IL2 0 plus. Okay, this is IL2 0 plus. So if I draw my circuit just at t equals to 0 plus, this impulse will be gone. Okay, it will be 0, it will vanish at t equals to 0 plus, and this will get instantaneously charged to 1 by L of current. This will have 0 amperes current, right? This will have 0 amperes of current, as there is some finite drop. So what will be the drop here? The drop, like this whole current will flow through this only, because there was finite voltage across this inductor, hence this inductor won't change this current instantaneously. So this current will be 1 by L. So drop across it will be what? R by L. But the drop across it will be minus R by L, because this is plus minus and this is minus plus. So drop across it will be minus R by L. You can use the KVL, whatever you find suitable, it will be minus R by L. So drop across it will be minus R by L. So VL2 0 plus is minus R by L. That means it is what? It is discharging, de-energizing. VL1 is plus R by L. That means it is charging. And what next? What about the so current is through that, is that, and what is IL2 of 0 plus? IL2 0 plus we have already computed. This is equals to my I of 0 plus, right? This is equals to my I of 0 plus, okay, which is 1 by L. Then at steady state, what will happen? At steady state, the drop across it will reduce, okay, and the drop across it will also reduce. It will go towards 0. This is also going towards 0. This is also going towards 0. And when both of them goes towards 0, there will be some constant current through both of them, which will get through the flux conservation equation. So which is L of L1 into not L1, because initially L2 had all the energy. L2 into IL2 0 plus will be equals to L1 into IL1 infinity plus L2 into IL2 infinity. So like, let me draw the circuit at infinity, you will understand. So we've already done this case. So if I draw the circuit at infinity, this will be the resistor, this will be the inductor with some current IL1, and this will be the inductor with some current IL2. This is R. This is obviously short circuit. So through here, like, current, the drop across this inductors are 0 volts, right? Drop across this inductors are 0 volts. This is source free. So as this 0 volts, obviously current through this will be 0 amps. So whatever current that flows through here will flow through here itself. So obviously my IL1 will be equals to IL2 itself. Okay, that is infinity, right? That is infinity. So L2 is L only, and IL2 0 plus was 1 by L equals to, this becomes L I will just write IL infinity times 2. So IL infinity is 1 by 2L simply, okay, amperes. And obviously my VO infinity is anywhere 0 volts, right? VO infinity is anywhere 0 volts. So VO infinity is anywhere 0 volts. So IO of infinity is simply IL2. So what is, like, this is my IO of infinity also. So what is happening? Initially I had current of 1 by L, then it reduced to 1 by 2L, okay. So initially I had current of 1 by L, then it reduced to 1 by 2L. And what about VO? So VO, obviously impulse voltage is coming across it, right? Initial, this is VO, right? This is VO, I haven't written it. This is VO of 0. So at t equals 0 impulse voltage is coming. Then as a impulse voltage is coming, then it suddenly becomes minus R while this is also VO 0 plus, and then at steady state we go to 0 volts itself, okay. So a impulse voltage will come of area 1, then it will go to minus R by L, then it will go to 0. So minus R by L, then it will go to 0. So this is 4 tau, and this is also 4 tau. So what will be the expression for this? The expression for this will be simply, if I write the expressions, it will be IO equals to 1 by L 1 minus, okay, not 1 by 2L 1 plus e raised to power minus t upon tau, okay. And this will be VO of t will be delta of t is there, then minus R by L minus R by L into e raised to power minus t upon tau, okay. So this will be my equations for voltage and current, okay. So okay. Now you can simply do one thing, you can do the poles and zeros. So what will be the poles and zeros? So again, I'll just do straightforward this time. Pole will be negative of magnitude of time cost, which will be same this time. Poles will be same, that is minus of L by 2R. So it will be minus 2R by L. So pole is at 2R by L, okay. And what about my zeros? So it's for zeros, I can take the circuit, not this. this. Can I break the link? Can I break the link? Yes, I can this time. So I have a opportunity to break the link, right? How? So this, right? This whole thing, if SL is equals to minus R, I can break the link. How am I telling SL equals to minus R? You can watch my realizing poles and zeros intuitively. Okay, that you can watch. So break the link. Okay, so if I break the link, what will happen? This will go to like SL, SZ, just hold on, SZ equals to minus R. So SZ equals to minus R by L. Okay, this is 1 0, and in this case, right, this is not going to infinity. Okay, there is some finite impedance, so this is not going to infinity, so this is a finite 0. Can I short the output? Yes, I can short the output. S going to 0, this will be short, but this will also be short, right? So if I short the output, what will happen? Basically, at S equals to 0, I can short the output, but like first of all, right, Z2 equals to 0, but Z1 is also going to 0. Same reasons, right? Same reasons as the previous case. Okay, so obviously no. Okay, so I can only use these case. We have only 1 0, and it is anyways we'll have only 1 0 because for a realizable system, okay, for a realizable system and for a system which is present in the real world, it can't have more number of zeros than the pole, because at high frequency the gain will be infinite, which is not possible. Okay, so my transfer function h of s will look something like this. It will be a into s L by R plus 1 divided by, okay, I don't have enough space, let me make this color to something else. Why am I running out of colors? I don't know. This will be S L by 2R plus 1. Okay, SL by 2R plus 1. Now what is the DC gain? DC gain is this case only, right? This case only. So DC gain, again, it will be 1 by 2, because if we short these two, they will provide low impedance path. Okay, they will provide low impedance path. So resistor I can ignore. So the voltage will get divided. So VO of 0 will be equals to VI of 0 into L by L plus L. So VO of 0 by VI of 0 is equals to 1 by 2. So this is equals to my A. Okay, this is equals to my A. So obviously my transfer function h of s will become 1 by 2 s L by R plus 1 divided by s L by 2R plus 1. Okay, so this will be my transfer function. So now I can simply draw the Bode gain plot. So this time the difference will be, I have to write the corner frequencies as well. So location of corner frequencies is important. So what is my 0 corner frequency? So 0 is R by L and omega p is 2R by L. So omega p is occurring later than 0. So first I will have some increase, then the slope will go to 0, and that is valid because at t equals to infinity, sorry, not t, at high frequency, what is happening? This is becoming 1 by 2 and this is also 1 by 2. So high frequency gain is 1. So obviously at high frequency my the Bode plot should end at 0 dB. So initially low frequency is half, so it is starting from negative, so there has to be some positive slope that will bring it to 0 dBs, and then it will be constant. So that is exactly what is happening, as 0 is occurring first. So 0 is occurring first, so this gain will be minus 20 log 2. Then I will have a 0 here, which will increase. Then obviously here I will have a pole which will make its slope to 0 dB per decade. So here the slope will be plus 20 dB per decade, and here the slope will be 0 dB per decade. Okay, so this will be the slope and this will be the Bode gain plot. What will be the Bode phase plot? It is similar, right? What will be it? So basically, if you observe correctly, again I have omega z equals to r by L, and omega p equals to 2r by L. So obviously this time again my pole is occurring later. So first I will get some phase lead due to the 0. Okay, as the effect due to 0 will come first, then my slope of the phase plot will be constant, because the effect of pole will also be applicable. Then plus 45 minus 45 becomes 0 dB per decade, and then again the effect of 0 will go away. So overall the slope will be minus 45 per decade, because the effect of pole is still remaining, and then again the effect of pole will also go away, and it will be, the slope will be 0 dB per decade. And where will it end? It will end at 0 degrees, because at s equals to infinity it is tan inverse 90, it is 90 minus 90, which is 0 itself. So it will start with 0 and it will end with 0. Where are all the beautiful colors? So it will be something like this. Start from here, okay, then here, 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 and here. What will be this point? What will be this point? So here, right here, the effect of 0 has just started, because the slope become plus 45 degree per decade. So obviously where does the effect start? It starts 10 times before the corner frequency. This effect will start omega z by 10. Then here the slope became 0 dB per decade just after it, because the effect of pole also has started. So here what will be the value of frequency? It will be omega p by 10, and in between it will be omega z, it will be omega p. Then here it will be 10 omega z, because just after this the effect of pole is only remaining. So 10 times after the effect of pole goes away, right? 10 times after this effect of corner frequency goes away, and here this will be 10 times omega p. The slope here is plus 45 degree per decade. Slope here is 0 degree per decade. Slope here is minus 45 degree per decade. You can try to compute this value, right? What will be this value? Okay, you can try to compute this value. So yeah, this will be basically the Bode gain and phase plot for the circuit. So we have analyzed completely the two circuits, which are very beautiful, right? These are very important circuits. So you try to analyze this intuitively. So now we'll solve this circuit. So we'll solve this circuit. So let's solve this circuit. So this has only a single inductor. So obviously the order will be 1. Okay, number of independent energy storing elements will also be 1. So obviously order will be 1. So order is 1. Okay, so single pole, again your response will be exponential. So response will be exponential. Okay, so like what will be my time constant? Again, if I just draw the circuit, right? If I just draw the circuit, make the independent source 0. Okay, make the effect of independent source 0. So this R and this R are again in parallel. So this will become, tau will be 2L by R. Basically L by R by 2, which will be 2L by R, right? So tau will be 2L by R. Now let's understand intuitively what will happen to the circuit at unit step response. So at unit step response, initially what is happening? Initially inductor has no flux, no energy. I am giving a voltage here 1 volts. So this will be open circuit, current will be 0. This will be open circuit, hence the voltage will get divided. Again there will be some half voltage applied across this inductor 1 by 2, which is positive. Current will increase, but the rate at which current will increase will decrease, because as it is driving more current, the current through here will reduce. If the current through here is reducing, that means voltage is reducing, so it will go to 0 at steady state. If it goes to 0 at steady state, it will be short circuit. So this current through here will be completely 0, current through here will be maximum. So here what will be the current will be 1 by R. Okay, so this will be 1 by R current. So at infinity, current is 1 by R, voltage is here, the voltage also 1 volts, because VO will be VI. This will become short circuit. At t equals 0, current will be what, 1 by 2R, because this is getting open circuit. This R and in series, and the what will voltage will be again half. So half to 1 volts, and current is going from 1 by 2 to 1 volt itself, because the resistor, I'm taking the voltage and current across the resistor, the shape will be same. So that is exactly what is happening. So phi of 0 minus equals to 0. So my IL of 0 minus will be 0 amps. Now if I draw just at t equals to 0 plus, circuit will be like this. This will be 0 amps. Okay, so rain has just come down. Sorry if some noise is appearing here. This will be 0 amps. So obviously the voltage here will be plus 1 by 2 plus 1 by 2, simple voltage divider. Okay, so if it is simple voltage divider, my VL of 0 plus will be 1 by 2 volts. So it is finite and it is greater than 0. Finite and it is greater than 0. So it will become here. So my IL0 plus and IL0 minus will be equal. So yeah, that is what this is. So obviously VO0 plus will be what, 1 by 2 volts. Okay, can apply KVL, and IO0 plus will be, this is IL, right? This is IL. IO0 plus will be simply 1 by 2 R. And at steady state, what is happening? Steady state, inductor is getting short circuited, R and R. This is 1 volts and this is my VU. Okay, so at steady state I can directly write this is at t equals to infinity, this is at t equals to 0 plus. So my VO of infinity will be simply 1 volts, right? Because this is short circuit, this is short circuit, so this node and this node will be same potential, and IO of infinity will be 1 by R, simply the voltage across the resistor divided by the resistance itself, 1 by R ampere. So how will my plots look like? So plots, right? IL, this is not IL, this will be IO and VO. So my IL, so my I0 is going from 1 by 2R, okay, 1 by 2R to 1 by R. So it will be something like this, okay, and the voltage waveform will be also similar, 1 by 2 volts to 1 volts, because it is across a resistor. So voltage and current waveforms will be similar. One by 2, this is not 1 by 2R, this is 1 by R, and this will be 1 by 2R, this will be 1 by 2, this will be not 1, this will be 1, and this will be 1 by 2R. Now can you write the expression for this? So this will be 4 tau, and this also will be 4 tau. Can we write the expression for this? The expression for this will be IO of t. So what is the infinity voltage, right? Infinite voltage, infinite current, this 1 by R. So 1 by R plus what is the current at t equals to 0 plus 1 by 2R minus the current at t equals to infinity into e raised to power minus t upon tau. Okay, so if we compute this, what will happen is that at like at t equals to infinity my current is this, and t equals to 0 my current will be this will get cancelled, and this will be the current, right? 1 by 2R, exactly what I am getting. So if I simplify this, okay, I need to simplify this. This will be 1 by R, I can take common 1 minus 1 by 2, okay, just hold on, gonna take 1 into like e raised to power minus t upon tau. So I can delete this now, can take this over here. Now what about the voltage? V of t, again, right? Same way it will be same, just multiplied by r. So 1 minus e raised to power minus t upon tau divided by 2. So this will be my voltage waveform. So let's talk about the impulse, unit impulse. So I think the rain is coming, so I may have to stop this now because there is too much sound right now. So what will be the impulse response of the circuit? So let me copy the circuit again, and if I have it, okay, I don't have it, so let me copy this circuit here, and let's see intuitively what is happening at the impulse response. So if I apply a impulse over here, then initially this inductor has no flux, so open circuit, so voltage will get divided, so this will be delta by 2. The voltage across the inductor will be delta by 2, right? So if it is delta by 2, obviously a impulse voltage is getting applied, so it is not finite, hence it will change its current instantaneously. So it will go to 1 by 2L current, and 1 by 2L current will flow, then this impulse will go away, so this will become short circuit, and this 1 by 2L current will discharge through this resistor and this resistor as well. So this voltage, this current will be what it will be 1 by 2L divided by 2, which is 1 by 4L. And what will be the voltage here? Voltage will be R by 4L, and current will be 1 by 4L, and it will go to 0 after that because this becomes a source free network. So that is basically the intuitive analysis of this RL circuit. So let's do this. So obviously we know initial flux is 0, hence initial current will be 0. But if I just draw the circuit at t equals to 0, if I draw the circuit t equals to 0, this will be plus minus delta of t, okay, and this will be obviously open circuit, so this will be open circuit, okay. Here 0 amperes of current will flow, so this will get divided into a voltage divider, so this will be delta by 2, delta t by 2 divided by 2. So overall voltage across this inductor at t equals to 0 will be delta by 2. So as it is delta by 2, delta t by 2, hence it is not finite, hence the current will change, right? Current will instantly change. So this will not be equals to IL of 0 plus, as some flux has been injected to this inductor. What is that like amount of current that will change? So LdIL dt will be equals to VL, and VL of 0 is delta by 2, so delta by 2 delta t by 2 equals to L DIL by dt. Now if I integrate, so my IL of 0 plus will be equals to 1 by 2L, okay. IL of 0 plus will be equals to 1 by 2L. So can I draw the circuit at t equals to 0 plus? So this is at t equals to 0. I'll draw the circuit at t equals to 0 plus. This will be replaced with the current source. This will be short circuited because impulse goes away just after t equals to 0. So as the impulse goes away, this will be 1 by 2L current, and here this is observing similar impedances, so obviously current will get divided. This will be 1 by 4L, okay. And what will be the drop? Drop will be simply R times 4L, R by 4L. So IL of 0 plus is this, IO of 0 plus will be 1 by 4L, and VO of 0 plus is R by 4L, okay. So VO of 0 plus is R by 4L. This is at t equals to 0 plus. Okay, and what about infinity? At infinity, this is a source free network. Obviously, as the voltage is reducing, current will also as the current is reducing, voltage will reduce, because the rate at which current is like decreasing, right? It is reducing. So this will also be short circuited. Here I have R. This is my VO. So everything is 0, right? So current across the resistor is also 0. So obviously my voltage will be 0 volts and my current will also be 0 amps. Okay, basically like whatever the resistor, like it is across the resistor, voltage and current waveform will be same. So this time how will my waveform look? So initially what is happening, initially if you observe here, right, what am I getting? Like am I getting some finite voltage or infinite? So this, right, at t equals 0, VL is delta t by 2, and the other delta t by 2 is across this voltage, right? So initially my output voltage is delta t by 2, that is the area of this impulse will be 1 by 2. Okay, then what is happening, suddenly my current became this 1 by 12, so my voltage is R by 12, so it starts from R by 12, and my current is starts from 1 by 4L, so it will start from 1 by 4L and it will go to a 0 t equals to infinity. And just the same thing is happening over here also. If I can somehow, so it will be simply R times that, right? It will be, okay, so hold on. Actually here one thing will be different, this, right, this area will be 1 by 2R and not 1 by 2. This will be 1 by 2, right? This area will be 1 by 2, and again same thing, just multiplied by R. So here this will start from 1 by 4L, this will be 4 tau, and this will start from R by 4L, and this will be 4 tau. Okay, so just what will be the equation will be very simple. It will go, there will be an impulse of area 1 by 2R plus 1 by 4L into e raised to power minus t upon tau, and the same thing for voltage as well, just multiplied by R, delta t by 2 plus R by 4L into e raised to power minus t upon tau. Okay, so now let's talk about the poles and zeros. So what will be the poles and zeros? So obviously first order circuit, so I can write poles as negative or inverse of magnitude of the time constant, or you can see infinite impedance. Okay, or make infinite impedance at the output node. You can make the infinite impedance at output node. So time constant is 2L by R, so my pole will be minus R by 12. Okay, so this will be my pole. And what about zeros? So for zeros, right, if I just paste the circuit, can I break the link? Can I make this impedance infinite? Yes, right, I can make this impedance infinite. So if my SL plus R goes to 0, this will be infinity. Why? Because you make the parallel combination and the denominator will have this term, and if this goes to 0, overall impedance will go to infinity. So obviously first what I'm trying to break the link. Okay, so obviously this is my this is my SZ equals to minus R by L. Okay, SZ equals to minus R by L. So this is a finite zero, right? Now what is the other option? Short the output. Can I short the output? Can I short the output? The answer is no, right? The output is not a function of frequency. Like the output impedance, like the Z2, right? It's not a function of frequency, so it will never vary. So the simple answer is no. Okay. The simple answer is no. So how my transfer function will look like? My transfer function h of s will look like a into 1 plus s L by R divided by 1 plus s 2L by R. Okay, so obviously I don't have it 0 at 0, so I can compute my DC gain, and from there I will be able to find my value of A. So at s equals to 0, what will happen? This will be open circuit because SL is 0. No, sorry, not open circuit, this will be short circuit. SL is 0, so this will have 0 impedance, so this will be short circuit, so this R will be gone. So obviously my VI will be directly equals to VO, because this is only a resistor, right, directly connected across this. So VO will be VI at s equals to 0. VO of s equals to VI of s. So VO of 0 by VI of 0 equals to H of 0. H of 0 is what? If you put 0 over here, so you will simply get A. So that is why we use DC gain to find the value of A, so which is equals to 1. Okay, so simply my transfer function H of s will be 1 plus SL by R divided by 1 plus S 2L by R. Okay, this will be my transfer function. Now let's compute the let's draw the Bode gain and phase plot. So HFS is this. So at s equals to 0, I have a gain of 1. Okay, I'm starting from 1. Now after that, like what is my, like where are my zeros and poles? So if I write here, right, my pole is at R by 2L and my 0 is at R by L. So obviously what I can observe, my 0 is coming after my pole. Pole is coming before 0. So pole is less than 0. So pole is coming before the 0. Okay. So obviously the effect of pole will come in first. So there first of all I will have 0 dB per decade slope. Okay, and it will start with from 0 dB because my 0 frequency gain is 1. So it will start from here. Then I am getting a pole. Okay, first I am getting a pole, then I am getting a 0. So first I will get a pole. So hence for that my slope will be minus 20 dB per decade. Then I am getting a 0, so that will cancel out the previous slope. So it will provide plus 20 dB per decade, and I had already minus 20 dB per decade. So overall my slope will become 0 again. Okay. So this is omega p and this is omega z, and here I will have a slope of minus 20 dB per decade slope, right? Here I will have a slope of minus 20 dB per decade. Now what will be this value? Can you tell what will be this value? This value will be simply the high frequency gain, right? This value will be simply the high frequency gain. Why? Because after this the slope isn't changing, so the gain won't also change. So Bode plot will approximate the high frequency gain. And what is the high frequency gain? What is h of infinity? H of infinity is, only I will use the coefficient, so it will be 1 by 2. 1 by 2. So if I do the log, it will be minus log of 2. So it is correct, right? So I'm getting minus. So obviously I'm below the 0 dB axis. So it will be minus log of 1 by 2. So the 2 will go in the front. So this will be 20 log of 2. Minus 20 log of 2. Okay. So this will be your like plot, basically Bode plot. So all of this I'm calculating because the interviewer may ask you, right, what will be the value here. So you have to compute that also. You just can't what do you say, mug up everything, right? You have to do conceptually there. Let's solve the phase for this. So the phase is what? So phase is a bit difficult, right? Phase is a bit difficult. Why? So obviously my pole is occurring first. Okay, what is my pole? Pole is R by 12. Now 10 times before this, right, omega p by 10 is R by 20L. Okay, and don't worry, they most probably they will not ask this. And 10 times after this is 10 omega p is 5 R by L. And now what about my 0? So 0 is R by L, right? R by L. So 10 times before this omega z is omega z by 10 equals to R by 10L. So if it is R by 10L, it is definitely higher than this. Okay, definitely higher than this, but lower than this, right? Lower than this. So this is lower than this. So obviously this, right? 10 times before 0, this will come into action. Okay, so this will come into action, and obviously 10 omega z will be higher than everything. 10 by RL will be higher than everything. So it will be at the end. Okay, so like how will my axis look like? So first of all, I will get omega p by 10. Okay, you can compute for yourself omega p by 10. Then I will get omega z by 10. So action due to 0 is coming. Then I will get omega p. Then I will get omega z. Then I will get 10 omega p. The action due to the pole, okay, is gone. Okay, the effect of pole is gone. Then I will get omega z. Now here the effect of 0 will also be gone. So initially, right, if my s is 0, I'm starting with 0 degrees. So I'm starting with 0 degrees. So I will start with 0 degrees. Then pole is coming, right? This is a pole, right? So obviously my slope will become minus 45 degree per decade. Then just here at this point, what is happening? I am getting like the effect of 0 is also getting started. So obviously due to this 0, my slope will be plus 45 degree per decade, and already I am at minus 45 degree per decade slope. So overall the slope will become 0 degree per decade up until where? Up until this 10 omega p, because just at this 10 omega p, what will happen? The effect due to pole will go away. So the overall slope will be plus 45 degree per decade, and due to the pole it is 0 45 degree per decade. So obviously overall will be plus, so it will increase. Okay, angle will go from negative to positive more. This will be somewhat like this. And at 10 omega z, what will happen? The overall angle will become again, like effect of 0 will also be gone. So overall slope will become again 0. And why will it stop at 0 degrees? Because if you see high frequency phase is what? 0. Like tan inverse infinity minus tan inverse infinity is 0 itself. So it will be 0 and it will settle at 0. Okay, and here the slope will be minus 45 degree per decade. Here the slope will be plus 45 degree per decade. So this will be the Bode phase and gain plot of this circuit. You can find out this point. They may ask you this point. You can try to find out this point. What will be this? What will be the value of this point? So yeah, let's start the next circuit. So let's start with this circuit. So this is simply, we have first time two RLs, right? Two inductors and a resistor. So are they dependent or independent? We can observe that if some current is flowing through this inductor, that the same current will flow through this inductor as well. So they are dependent with each other. So number of independent energy storing element is 1. So order of the circuit will be 1. Order of the circuit will be 1. That means single pole means exponential response. So if I am getting exponential response, okay, so like we can simply derive it intuitively. So obviously my time constant will be what? So as two inductors are in series, it will be 2L by R. L equivalent upon R equivalent. So L equivalent is 2L and R equivalent is R. So 2L by R. Okay, so now let's understand intuitively what will actually happen to the circuit. So if I just copy this circuit and paste it over here, now if I am giving a unit step voltage, what will happen? The inductors are unenergized, so they will be open circuit. So current through it will be 0. The voltage drop across this will be 0. So that whole 1 volts will be across this two inductors which have similar inductance. If they have similar inductance, what will happen? The voltage across them will be equally divided, 1 by 2 and 1 by 2, which is again finite. So obviously the IL equation will hold that the current before IL0 minus will be equals to IL0 plus, which is 0. So current will be 0, but as the voltage is positive, current will slowly increase. As dIL by dt is positive, hence it will increase, but as IL increases, this drop will increase, so overall voltage across the inductors will decrease. So the voltage across the inductors decreases, that means the rate at which current was increasing is decreasing. Obviously the voltages also will decrease, and at steady state it will go to 0. So voltage will go to 0 at steady state. Both of them will become short circuited. Okay, so that is what will happen intuitively, right? So let's now derive it. Obviously, so initial flux is 0 as energy is 0. Okay, so my IL 0 minus is 0 amperes, and if I just draw the circuit at t equals to 0 plus, this inductor will be open circuited, this inductor will be open circuited, okay. So voltage across them will be same, voltage across them will be same. So VO first of all I will compute for VL. VL will be simply 1 by 2 volts. It will get divided between the two. Okay, so this is at t equals to 0 plus. So it is finite. As it is finite, hence IL 0 minus will be equals to IL 0 plus. Okay, so obviously the flux will increase, and as the flux as VL is positive, flux will increase, flux increases, current will also increase. Okay, and at steady state what will happen, let me just write the currents. So IL is also equals to IO, so IO 0 plus is 0 amps, and VO 0 plus is 1 by 2 volts, right? 1 by 2 volts. So that is VO 0 plus. Now if you draw at steady state, both inductors will become short, because the changing current will be 0, because they will reach steady state. This is 0 volt, this is 0 volt. So overall what will happen, my VO will be 0, and what current will flow, my IL infinity is what, 1 by R. This is okay, I need to change this to 1 volt, right? One by R, which is equals to my IO infinity as well, and my VL infinity is equals to my VO infinity, which is 0 volts. Okay, so this will be steady state. So how will my plots look like? So current will go from 0 to 1 by R, voltage will go from 1 by 2 to 0. Okay, so basically it's a differentiation of the current itself, as it is across the inductor, right? So it will be differentiation of the current itself. So this will be 1 by R, and this will be 1 by 2. This will be 4 tau, this will be also 4 tau. The equation will be this will be IL, this is IO and VO actually, which are same as inductor and voltage current. So IOT equals to 1 minus e raised to power minus t upon tau. Obviously we have to multiply a 1 by R as well. Okay, and VO of t is equals to 1 by 2 into e raised to power minus t upon tau. Tau is 2L upon R. Okay, so that is it for unit step response. Now let's understand intuitively what will happen for unit impulse response. So if an impulse is given across this, obviously instead of that voltage becoming half, it will be delta by 2. Okay, delta t by 2. So if it is delta by 2, obviously current will change instantaneously. So both of them will carry same amount of current, which is 1 by 2L, and after that this will become short circuited. So 1 by 2 will flow through this resistor. So both of these inductors will get instantly energized, then they will de-energize through this resistor together. Okay, obviously this is source free network, so they will de-energize to 0 amperes, current, voltage, everything will go 0, as this is a source free network. So that is what will happen if I give a unit impulse. as my source. So let me just draw the circuit at t equals to 0. If I draw the circuit at t equals to 0, this is open circuit, this is open circuit, and this is plus minus delta of t. Okay, so this will be plus minus delta t by 2 delta t by 2. Okay, so this is it. This is at t equals to 0. So obviously this is getting divided because here the current is 0, right? So drop is 0. So this whole delta of t is coming across this both of these inductors. So obviously we'll start off with the flux equation itself. So initial flux is 0. Okay, initial flux is 0, hence my initial current will also be 0. Okay, but the problem is it will not be equals to IL 0 plus, as current will change, as my VL 0 is delta t by 2. Okay, so obviously this is not finite. As it is not finite, what will happen? Both of these will not be equal. Okay, so what will it be equal to? It will be simply 1 by 2L again. Okay, so IL of 0 plus will be, if I integrate it, integration of 1 by L delta t by 2 dt. So this will be equals to 1 by 2L amps. Okay, so what will my circuit look like at t equals to 0 plus? So at t equals to 0 plus, obviously the source will be gone. Okay, source will be gone, it will be short circuited, and my inductors will be replaced with the current source of 1 by 12. One by 12. Okay, so it will replace with 1 by 12 at t equals to 0 plus. So now what will be my output voltage? Can I directly say my output voltage? No, right? I have to measure the voltage across this resistor, then only I can comment about the voltage across this current source. Okay, so what will be the voltage across this resistor? The voltage across this resistor will be, this current is 1 by 12, so this voltage across the resistor will be R by 12. Now the thing is that these two inductors are same. So if these two inductors are same, the rate at which the current will decrease will also be same. If it is same, obviously the voltages will also be same. Hence this overall whatever drop this will get divided between these two, and this is from this side. If I am looking, this is negative. So here negative plus R by 4L. So the voltage across the output or the inductor will be minus R by 4L. And why is the negative sign? Why does the negative sign make sense? Negative sign makes sense because this inductor should discharge, right? This inductor should discharge as it is losing out energy. Okay, initially it charged, so voltage was delta t by 2, so it gained some energy. Now it has to lose energy because it is a source free network and the current, the resistor is dissipating energy. So obviously inductor will lose energy, whatever energy is stored. So obviously it will be negative. That's why it is negative. So at t equals to infinity, what is happening? T equals to infinity, everything will be 0, as like the current won't change. So obviously dIL by dt will be 0. Hence the voltage across the inductor will be 0. This is anywhere 0. Okay, so my VL of 0, not 0, sorry, VL of infinity equals to VO of infinity equals to 0 volts, and IL IL of infinity equals to IO of infinity equals to 0 amps. So how will my plot look like? So initially the current was 0, okay, then it suddenly went off to 1 by 2L. So 1 by 2L, the current went to 1 by 2L, then it gone to 0, okay, exponentially, as this is a first order circuit. So, and what about the voltage? So initially I got a impulse voltage, right, delta T by 2. So initially I had a impulse voltage here, area was 1 by 2, and then voltage became negative because it was discharging. So voltage become negative to R by 4L, then it went to 0, okay. So 4 tau, and this will be what? This will be simply 1 by 2L and what will be the equations? So equations here, this will be IO of T will be simply 1 by 2L e raised to power minus T upon tau, and VO of T will be simply delta T by 2 minus R by 4L e raised to power minus T upon tau, okay. So this will be my voltage and current equations. So like what about the poles and zeros? What about the poles and zeros? So poles for this will be inverse of the time constant. So if I draw the circuit over here, it will be inverse of the time constant. SP will be 1 by minus negative inverse of the time constant 1 by it was 2L by R, so it will be minus R by 2L, okay. Or if you want to make infinite impedance form here, so this R plus SL should be equals to minus of SL, right? R plus SL should be equals to minus of SL, then you will see that it will be minus R by 2L again. For zeros, how you will do? So you have to either break the link or short the output. So breaking the link isn't possible. Only at S equals to infinity we can break the link, okay. So break the link, I will just use some different pen. Break the link means S tending to infinity, not finite. This is not finite, it's not possible. Now can we short the output? Can we short the output? So I can short the output at S equals to 0, right, which is finite, hence this will be a 0. So if I have a 0 at S equals to 0, so obviously I won't be able to comment about DC gain, because DC gain will be 0 itself, because my transfer function will be like a form here, 1 plus S, where did it go, where did the pole go? Yeah, 2L by R, okay. HOS is 1 plus S 2L by R, okay. So now, like obviously DC gain will be 0, so what about my high frequency gain? I have to take the help of high frequency gain. So high frequency gain. So what will be high frequency gain? Let me draw the circuit. At high frequencies, what will happen is that it's like the T equals to 0 gain only of unit step. High frequency, this inductance and this inductance will provide very high impedance with respect to this R. So this R I can neglect. So this R will be neglected anyways. So the whole drop will come across these two inductors, okay. Whole drop will come across these two inductors. So obviously my VO of S equals to Vi by 2, it will be just like voltage division, because both of this inductance will provide very high impedance of same value, okay, because both of them has same L, right? So provide high impedance of same value. So VO of S over Vi, this is at S equals to infinity, equals to 1 by 2 and which is equals to h of infinity. Now if this is h of infinity, only the coefficients of s will remain, so this will be a by 2l by r. So obviously my a will be l by r. Okay, so v over vi of s is l by r, so my h of s will become s l by r divided by 1 plus 2 sl by r. Okay, so it will be 1 plus 2 sl by r. So what will be the Bode gain and phase plot? So if I just the color didn't change apparently, can change it again. So obviously we can see at zero frequency my gain is 0, so it will come from negative infinity. Okay, and I have a 0 at s equals to 0, so obviously initial slope will be positive. Then at s equals to 2 r by 2l, so my pole here corner frequency is r by 2l, I am getting a pole, right? So the slope will become 0 dB per decade, and at s equals to infinity I have half as high frequency gain. So obviously what will happen is that it will be lower than the 0 dB axis, right? So as the gain is high, so as the gain is half, okay, so it will never go above the 0 dB axis. So this will be like this. Similarly, we have done this already previously, so you can take reference of that. So this will be 20 log 2 minus 20 of log 2. Okay, so this will be that. Just hold on, I'm checking something. Minus 20 of log 2, and here the slope will be plus 20 dB per decade, and here the slope will be 0 dB per decade, and the corner frequency, this is the corner frequency. Okay, and what about phase plot? Phase plot will be similar again, right? So initially, if I, what angle is this 0 contributing? It is contributing always plus 90 degrees angle. So as it is contributing always plus 90 degrees angle, I will start from plus 90, then at 10 times before this omega p, and 10 times after this I will have a slope of minus 45 degree per decade. Okay, so it will be somewhat like this. So here this will be omega p by 10, this will be omega p, this will be 10 omega p, this will be like, this will be plus 90 degrees, and it has passed 1 decade, so this will be 45 degrees, and this will be 0 degrees, right? At s equals to infinity I am getting 0 degrees as my angle, and this will be minus 45 degrees per decade, this will be 0 degrees per decade, and this will be 0 degrees per decade. So this will be my Bode phase plot. Nothing new, like nothing new. So we have already done this type of Bode phase plot previously. So let's do it for this next circuit. So next circuit is this one. So can you comment about the order of the circuit? What will be the order of the circuit? So here, right, I don't have a resistor present. So I don't have a resistor present, even though I have two energy storing elements. But as I don't have a order, as I don't have a resistor present, what will be the voltage? Voltage will be simple voltage division between these two. So voltage will always be equals to Vi by 2. So Vo by Vi is equals to 1 by so this becomes a zero order circuit. This becomes a zero order circuit. Okay, so this becomes a zero order circuit. So this is not even a first order circuit. So Vo will be equal, Vo Vi will be always 1 by 2. So can you comment about intuitively what will happen? Intuitively what will happen here is that, okay, this one is copied, sorry. So intuitively, basically, if I put a 1 volt source over here, the voltage will get divided half and half. So what will happen? It is finite, so it will like current will increase and current will always increase as the voltage is constant. Okay, it is 1/2 always. So 1/2 equals to L di by dt. So current will increase in a linear fashion. Current will always increase, right? So obviously you can observe that at t equals to 0 plus, there is no flux obviously here initially. So initial current is 0 amps, and at t equals to 0 plus, if I draw my circuit, this will be open circuit and this will be also open circuit, and here I have given a 1 volt source. Okay, and it is getting divided between these two, right? These two. So this is also half volts, this is also half volts. But what is the problem now? The problem is there is no resistor through which the voltage is getting reduced, due to which the voltage is getting reduced as the current is increasing. So there is no energy dissipating element. So as there is no energy dissipating element, obviously the current like rate of change of current will be constant because the voltage is constant. So what is happening? This VL of 0 plus is half, which is finite, right? Finite, as this is not an issue here. This will be equals to IL of 0 plus, but the problem is this is constant and this is always greater than 0. Okay, this is not reducing, half is not reducing. So as it is not reducing, flux will always increase inside the inductor. So flux is always increasing inside the inductor. So basically my current will be what? Half is equals to L dIL by dt. So IL will be equals to 1/12 times t. Okay, again rain has come off, so that is a bad news. So it will again produce some sound. So we'll manage somehow. Let me just bring this very close. Okay, but I won't be able to cover the sound of rain. So yeah, IL will be equals to 1/12 t. So I'll just stop the video right now. Okay, after the rain goes off, again I will restart. Okay, so rain has been stopped finally, so I can restart. So I was talking here the current, right? Current will be some ramp function, because here some constant voltage is always getting added to it, so it will always increase linearly. So my initial voltage is finite, that's fine. So IL 0 plus will be finite, but after that it will be a ramp function. So my current, like at infinity, right? This is at t equals to 0 plus. So my VO of infinity will be what? VO of infinity will VO of 0 will be what? VO of 0 plus will also be 1/2 volts, and obviously IO of 0 is 0 only, 0 amperes only. Okay, and what is happening at infinity? So infinity, my obviously there is some constant voltage applied across it. So if there is some constant voltage, the current will always increase, keep on increasing, right? Okay, current will always increase, I, and this is 1 volts. So what will be the current? The current will be IO or IL equals to 1/12 into T. So this will be my current, right? And voltage is what? Voltage will always be 1/2. Voltage will always remain 1/2. Okay, as is a first order circuit, voltage will not change. Sorry, not first order, zero order circuit. So voltage will certainly go from 0 to 1/2. Okay, then it will remain at 1/2, and here it will increase linearly. Okay, so this is t by, the slope is t by, not t, sorry, the slope is 1/12. Okay, and obviously the equations are this is IO and VO. IO of t equals to t/12, and VO of t equals to 1/2 volts always. Just the integration of this, right? Just the integration of this. So yeah, that's pretty much it for this question. So let's go to the impulse response. So impulse response will be similar. Okay, if I just copy and paste the circuit. Okay, this is not the circuit, this circuit, right? So if some impulse voltage is applied across it, obviously the inductors will get instantaneously charged to 1 by 2L current. Okay, so at t equals to 0 plus, the circuit will look something like this. If I just paste it again, so this will be obviously what the voltage will get divided to plus minus delta of t by 2, right? So what will be the intuitive approach? So obviously voltage will get divided to delta t by 2 on both of these, so inductors will get instantaneously energized to 1 by 2L of current. So both of them will flow 1 by 2L of current, then this impulse will be gone, and this is short circuit, right? So voltage across the inductor become 0 instantaneously. So if that becomes 0 instantaneously, so it will reach steady state, and it always in this circuit, always 1 by 2L current will keep on flowing because the voltage has been 0, so the rate of change of current is 0, so current won't change. So inductors will reach steady state at that t equals to 0 plus itself, okay, and they won't change. So current will be always 1 by 2L, and voltage across this inductors will be 0 volts, okay. As current is not changing, they have reached steady state. So that will be the intuitive approach. So delta t by 2, again I will start my analysis with initial flux is 0, initial current will be 0, okay. But what about the current at t equals to 0 plus? This is at t equals to 0 itself. So VL of 0 is delta t by 2, not finite, hence it will not be equals to IL of 0 plus, okay. It will not be equals to IL of 0 plus, so they will get instantly charged to what current? So IL of 0 plus will be integration of 1 by L delta t by 2 dt, so it is simply 1 by 2L of current, okay, 1 by 2L of current. So at t equals to 0 plus, how will my circuit look? My circuit will look somewhat like this, okay. Impulse will be gone, so it will be short circuited, it will be replaced with a current source, it will also be replaced with a current source of 1 by 12. So here, right, this inductors, both of them are same, and here the voltage is 0, so voltage across these two will also be 0, hence the current won't change, then the VL will be 0 again. So this has reached steady state instantaneously, okay, and it will remain that way, as there is no resistor to dissipate the energy, okay. This is a source free network, but there is no resistor to dissipate the energy. So IL VL of 0 plus will be 0 volts, okay. VL of 0 volts will be 0 volts, and which will be equals to infinity itself. So how will my waveforms look like? My waveforms will look like that IL will go from 0 to 1 by 2L, suddenly it will change, and then it will remain at that point, okay, 1 by 2L, and VO, a impulse voltage will come across it of magnitude delta of 1 by 2, area of 1 by 2, then the voltage will become certainly 0, okay, it will go to 0 certainly. So if you just integrate this, you will get this, okay. So it is like an impulse signal itself. So voltage across the inductor is like an impulse signal itself. So obviously we know, right, O will be always VI by 2. So that is exactly what is happening over here. So IO of t equals to 1 by 2L into U of t, and VO of t equals to delta t by 2, okay. So yeah, this is how this will look. So transfer function is nothing, so H of S will be what? H of S will be simply 1 by 2, okay, very simple. And obviously here, if H of S is 1 by 2, so my Bode plot is independent of frequency, 0 order circuit, so it will always remain here, right? minus 20 log of 2. And phase plot, like phase plot will be 0. There is no phase angle, right? There is no phase angle, so phase plot will always be 0. Okay, so let's solve this next circuit. Next circuit is again similar, right? We have a series like two inductors in series, right? But here just the R is present over here instead of here, right? We just analyze the circuit. R is present over here. So basically again, what is the order? Order is 1. Order is 1, right? So it will be exponential response. So if exponential response, there will be single pole, and like time constant for first order circuit is what? It is two inductors are in series, 2L by R, basically L equivalent upon R equivalent. So it will be 2L by R. Okay, just hold on a second, let me check if everything is fine. Yeah, it will be 2L by R, right? So how will the response look? Let's go to the intuition. So now if I have applied a step voltage over here, this has 0 current, this has 0 current, so they both of them will provide high impedance. So this resistance I can neglect. Okay, current is 0, so voltage drop across it will be 0. So these two inductors, the drop will be divided between these two. Okay, and it will be 1 by 2. If it is 1 by 2, voltage across the inductor is positive, current will increase. Okay, rate of change of current is positive, current will increase, but then some drop will occur across it. So what will happen is that overall voltage across these two inductors will reduce. Okay, they will be same. Okay, they will be same, but they will reduce, and further drop will happen over here. So the voltage across the inductors are reducing, hence the rate of change, the rate at which the current is increasing is reducing. So the rate will go to 0 at some point of time. So voltage will go to 0 at some point of time, and then current won't change anymore. It will reach steady state. So at steady state, this will be short circuit, this will be short circuit. Overall current will be 1 by R. Okay, so it will go from 0 to 1 by R. But voltage waveform will be interesting, because the voltage waveform is the summation of voltage across the resistor and the inductor. So that is the interesting point over here. So obviously initial flux is 0. Okay, initial flux is 0. There is no energy in the circuit. Initial current is 0. And if I compute the circuit at t equals to 0 plus, basically this will be open circuit, this will be open circuit, plus minus plus minus. So here, like the voltage, this will be a 1 volt. T equals to 0 plus, okay, voltage will be divided to between them, because here the current will be 0, right? So VL of 0 plus is 1 by 2, hence which is finite but greater than 0 but finite. So it is finite, so obviously it will be equals to IL of 0 plus. Okay, so it will be equals to IL of 0 plus. So my IO of 0 plus equals to 0 amps. But what is my VO of 0 plus? VO of 0 plus equals to VL of 0 plus VR, the drop across the resistor. So it is equals to VR is 0, so it will be VL, which is half. Okay, so VO of 0 plus is half simply. So what about infinity? Infinity, both of them are going to steady state. So if both of them are going to steady state, it will be somewhat like this. This will be 1 volt. So simply circuit, what will be V of infinity? V of infinity will be simply 1 volt, right? So this overall will get in here, and IO of infinity will be 1 by R, and VL of infinity is obviously 0 volts, as it has reached steady state. So now we can draw the waveform. So simply current will go from 0 amperes to 1 by R. Okay, current will go from 0 amperes to 1 by R. And voltage, what will voltage happen? Voltage, it will go from half volts to 1 volts. Go from half volts to 1 volts, and response will be obviously exponential, as this is the first order circuit. So this will be 4 tau, this will be 4 tau. Now what will be the expression? Expression of IO of t is easy only, so it will be 1 by r into 1 minus e raised to power minus t upon tau, and this VO of t will be what? VO of t will be, now initial voltage I have half, and steady state I have 1 volt, so 1 plus 1 by 2 minus 1 e raised to power minus t upon tau. So this becomes 1 by 2 1 minus 1 by 2 into e raised to power minus t upon tau. T upon tau. Okay, so this will be the equation. Okay, now what about unit impulse response? What will happen to the impulse? So if I just page the circuit again, so if an impulse is flowing over here, obviously it would get divided into delta by 2, so both of them will get instantly charged to 1 by 2L of current. So 1 by 2L of current will flow, but then this impulse will go away, this will become short circuit, and there is resistor, so there will be like these two inductors will de-energize through this resistor. So at the end it will go to 0 volts and 0 amperes current. Okay, so yeah, that is how it will become. So very simple, right? So if I draw the circuit for 0 plus, not 0 plus, exactly t equals to 0, this is open circuit and this is open circuit, this is R, this is my VO, right? So obviously here some delta t by 2 will come, and here also some delta t by 2 will come at t equals to 0. So what is happening? So inductor has no flux, so obviously this is 0, so I of 0 minus is 0 amperes, and what is happening? My VL of 0 is what? VL of 0 is delta t by 2. Okay, so VL of 0 delta t by 2, which is not finite. So obviously my IL of 0 plus will not be same, it will charge up instantaneously to what value? To 1 by 2L value. Okay, so it charge up instantaneously to 1 by 2L value. Next, how will my circuit look? So there, here will be 1 by 2L. Okay, so next what will happen? Next basically this at t equals to 0 plus and at t equals to infinity. So t equals 0 plus, what are the values? So the most interesting part is, what is the drop across this? The drop across this is what? It is R by 2L, and R by 2L will get divided into both of this, right? Why? Because like they are same only, inductors have same value, similar value, and all of them the voltage across them is this R by 2L, so it is de-energizing, right? So it will be negative, so this voltage will be minus plus R by 4L, and this also will be R by 4L. So overall my VO of 0 plus will be what? It will be minus R by 4L, right? Basically this voltage, whatever this was, this is getting divided between these two, as they are inductors of same value. So VO of 0 plus will be, so not VO of 0 plus will not be minus R by 4L, actually it will be VL of 0 plus, and VO of 0 plus is simply VR plus VL. So R by 2L minus R by 4L is R by 4L. It will be plus R by 4L, not minus R by 4L. Now at infinity everything is going to 0. Okay, this will be short circuited. this will be short circuited. So obviously this will go to 0 itself. Okay, so VO of infinity will be 0, IO of infinity will also be 0 amperes. Okay, so my plots will look how. So my current, what was my initial current? So my initial current was, if I observe here, initial current was 0 amperes, then it became suddenly 1/12, then it goes to 0. Okay, so 1/12 and it went to 0. What about my voltage? So initial voltage was delta T by 2. So it was delta T by 2. Then it is still positive, which is R by 4L. Then it go into 0. So this will be 1/12, and this will be 1/2 impulse, and this will be R by 4L, and this will be 4 tau, and this also will be 4 tau. So the equation is very simple. IO of t is basically 1/12 e raised to power minus t upon tau, and VO of t is basically delta T by 2 plus R by 4L e raised to power minus t upon tau. Okay, so this will be my simply equation for both of the currents and voltages. Okay, so just hold on a second. This is delta by 2. Yeah, delta by 2. Yeah, this is fine, right? Delta by 2 current and by 2. Yeah, so the currents and voltages will be like this. So now let's go to the poles and zeros. So if I see the poles and zeros, like poles is simple only, right? Poles is simple only. What I can do, either you can make the admittance 0 from this node, or you can make the impedance infinite from this node, or you can just do the inverse of magnitude of time constant. So I will do that only. So magnitude of time constant, so time constant was 2L by R, so it will be minus R by 2L. Okay, so what will be my zeros? My zeros will be basically either I have to break the link or short the output. Can I break the link? At s equals to infinity, I can break the link. Okay, and which is not finite, right? Not finite, so this is not a finite 0, and I can short the output with what? If my R is equals to minus of SL. So this is finite again, and obviously this won't go to 0 at that point of time. So my S0 SZ will be minus R by L. Okay, so how my transfer function looks like? My transfer function will look something like this: A S L by R plus 1 divided by S 2L by R plus 1. Okay, so obviously my DC gain is finite this time. What is my DC gain? If this is 0, this is short circuit, so Vi equals to VO. Simply DC gain is Vi equals to VO. So this will become short circuited, this will become short circuited. So VO of S equals to VI of S. So VO of 0, Vi of 0 equals to 1, which is equals to my A itself. Okay, as this is equals to my H of 0, which is equals to my A. So you have got A, everything, right? So your H of S will be S L by R plus 1 divided by S 12 by R plus 1. Now we can plot the Bode plot and all those things, right? So if I just copy this transfer function, if I just copy this transfer function, what will be this? So here h of s is SL by R plus 1 and this is S12 by R plus 1. So what is my pole? Pole is like corner frequency of pole is R by 12 and corner frequency was 0 is R by L. So obviously 0 is greater than pole, right? 0 is greater than pole, so pole will come first. Okay, at DC I have one gain, so that is 0 dBs. So I will start from 0 dBs and pole will come first, so I will then go to minus 20 dB per decade, then a 0 will come and that will make my slope as 0. So this will be omega z, this will be omega p. Okay, and what will be this value? What is the high frequency value? High frequency, if we compute here, high frequency is 1 by 2. So this will be minus 20 log 1 by 2. Basically plus 20 log 1 by 2, which is minus 20 log 2. Okay, so yeah, this will be something like this only. So this is minus 20 dB per decade. Okay, so this is how this Bode gain plot will look. Let's do the Bode phase plot. If I do the Bode phase plot, initially what is happening? Initially this is 0, this is 0, so obviously my phase is 0. Then like this will be like a trapezoidal. My omega, so basically what will happen, my omega p is R by 12, which will come first, then omega z, right? But 10 divided by omega p by 10 will be R by 20L, omega z by 10 will be R by 10L, omega 10 omega p will be 5 R by L, 10 omega z will be 10 R by L, right? So what will happen here? Sequence of events will happen. So first I will get omega p by 10. So obviously my slope will go negative first. Then I will get omega z by 10. Then I will get omega p. Then I will get omega z. Then I will get 10 omega p. The effect of omega p will be gone. Then I will get 10 omega z. The effect of omega z will be gone after here. Okay, so this, then this, then like after this, right, the effect of pole has been occurred. So here I will get a slope of minus 45 degree per decade. After this, the effect of 0 is also occurring. So obviously this slope will get cancelled with this effect of 0. So this will be plus 45 degree per decade, and it will remain until this pole, and this pole after this, right, the effect of pole will be gone. So my slope, overall slope, will be plus 45 degree per decade because the effect of 0 is still present. So it will be plus 45 degree per decade and it will end at 0. Why it will end at 0? I have mentioned in one of the previous examples, right? So here this will be minus 45 degree per decade, this will be plus 45 degree per decade, and this, right, this will be what? This you have to compute. This will be what value? This you have to compute. Okay, so yeah, this is how your Bode phase plot will look like. Okay, so yeah, now we'll solve the next few examples. Okay, so this circuit is very interesting because we have to only plot the voltage, because plotting the current will take up so much time, and there will be many cases for understanding this circuit, okay, for the step and impulse response. So first of all, what is the order of the circuit? So at first glance, this may look like a second order circuit, but if you observe this carefully, right, if I remove the independent sources, what will it become here, right? If I observe, this point is A and this point is, let's name this point as B. So this AB is across this L1, this A and this B is across this L2 as well. So L1 and L2 are in parallel. Similarly, R1 and R2 are also in parallel, right? So obviously number of independent energy storing elements is 1 only. So order is only 1. Number of independent energy storing elements is 1. So order will be 1. Order will be 1. Okay, so order is 1. So like we can observe, right, L equivalent here as it is parallel, so L1 parallel with L2 and R equivalent is simply R1 parallel with R2. My time constant for the first order circuit is defined as L equivalent by R equivalent, so it will be L1 parallel with L2 divided by R1 parallel with R2. I will not write it. Okay, so this was my time constant. Let's understand about the step response. So if I have unit step, what will happen to the circuit actually? So we have to divide this in 3 cases, right? We will divide this into 3 cases. So first of all, I will vary my resistance now. So what I will do, I will choose my inductors as same and resistors as different. Okay, so my resistors will be, okay, I will vary only my resistors. Inductors will be same only. L1 equals to L2. Okay, L1 equals to L2 equals to L. Okay, so here I will choose that this is always the case that L1 equals to L2 equals to L, and I will vary my R, because if I vary everything it will be very confusing for you. Okay, so choose case 1. Case 1 is what? My R1, I will choose my R1 as low, R by 4, and R2 as 3R by 4, just to make this overall R, right? Just to make this overall R. So now what will happen is, let me talk intuitively. Initially inductors are unenergized, so they will be open circuit and there will be voltage division between R1 and R2. So this inductor will have voltage 3 by 4 and this inductor will have voltage 1 by 4. Both of them finite, both of them positive. So obviously they will take some current, right? They will take some current, they will charge, they will energize. Next what will happen is that then still we have this 1 volt, right? Still 1 volt is there, and there is some there is some voltage across it, so there is some current across it, and what will happen is that it will take some current, this will also take some current. So if this takes some current, the current across this reduces, the current across this reduces. So if the current across this reduces both of the resistors, then the voltage across the resistors will reduce, then the voltage across the inductors will reduce. If the voltage across the inductors will reduce, that means the rate at which the current was which it was energizing has reduced. That means the voltage will tend to go to 0 at steady state. So if the voltage goes to 0 at steady state, what will happen? This will be short circuit, this will be short circuit. Then obviously this has 0 voltage across it, this has 0 voltage across it. So overall the voltage becomes 1 by 2, right? 1 by 2. But you might say, sir, then the voltage has been 1 by 2, so how will the current look like? So there will be some current, that current will be, extra current will be provided by inductor itself and the source itself, right? But as this will provide at steady state, okay, at steady state there will be some constant voltage across it. Okay, there will be some constant voltage, so it will provide some ramp current, and due to that there will be some constant voltage, it won't go to 0. Okay, it will try to provide very low impedance as it provided at steady state as it provides very low impedance. So this R1 and this R2 we can ignore. Okay, so they will, this L1 and L2 will be in series, as L1 equals to L2 equals to L. So overall voltage division will happen, which will be 1 by 2. Okay, so as steady state this inductor will give some ramp current, this inductor will also give some ramp current, the voltage across it will be half. Okay, that's the analysis. You can do the current analysis by yourself. So current analysis is homework for you. Like you analyze what is the current through this, what is the current through this, what is the current through this, what is the current through this. Okay, both of them will be different. But one thing you can observe, whatever the current is going here, right, it in is becoming same over here. Okay, so that concept also you can use. So now we'll do the calculations. So if I just copy the circuit, I know my initial flux is 0. So if my initial flux is 0, that means my initial current IL0 minus will be 0. Okay, and what about at t equals to 0 plus? So at t equals to 0 plus, this is getting open circuited and this is getting open circuited. So both of them are getting open circuited, and this is 1 volts. Okay, this is 1, this is plus, this is minus. Okay, so what will happen? This is R by 4, this is R by 4, and this is 3R by 4. Okay, and this is my V of 0 plus. So VO of 0 plus, VO of 0 plus equals to VL of 0 plus, VL2 of 0 plus, which is L itself, equals to 3 by 4, right? Which is greater than 0, but it is finite. So IL of 0 plus, IL of 0 plus, IL2 of 0 plus will also be equals to 0 ampere. Similarly, IL1 of 0 plus will also be equals to 0 amperes itself. But at steady state, what is happening? At steady state, both of the inductors will dominate, as they will provide low impedance path. So inductance will provide low impedance path at steady state. So at steady state, they provide low impedance path. So obviously this will be like short circuit, and this will be also like short circuit, right? And if these are short circuit, then the voltage across them is 1 by 2 and 1 by 2, simple voltage division, as both are L. And if the voltage division is that, so I will have a steady state voltage. I will have a steady state voltage of VL of infinity equals to VI of infinity, not VI of infinity, sorry, equals to VO of infinity. This is VL2, which is 1 by 2 volts, and this will be exponential. This is first order circuit, this will be exponential. Okay, so basically what is happening here, if the L's are different, you can compute like this, that half is coming like simple voltage division at L plus L plus L into 1 volts, which is 1 by 2 itself. Okay, so obviously how will my graph look like? So initially I had 3 by 4 voltage, then it went down. Okay, this was due to the resistance, right? This is 1 by 2 and this is 3 by 4 volts. Okay, and this is simply 4 tau. So my equation will look like VO of t will be equals to simply 1 by t, 1 minus, now at t equals to 0, this has to go to 3 by 4. So I need 1 by 4 also, 1 by 4 e raised to power minus t upon tau. Okay, 1 by 4 is to power t minus, oh, this will not be 1 by 4, this should be 1 by 2. So you can compute, this will be like this. Now for case 2, right, for case 2 I am choosing R1 greater than R2. What will happen? Just the difference will be my VL of 0 plus equals to VO of 0 plus. This time, instead of becoming 3 by 4, it will become 1 by 4. Okay, 1 by 4. So my circuit will look something like this. This will be open circuit, this will be open circuit, this will be 1 volt. So this will be 3R by 4. R by 4. Okay, so this voltage will be simple by voltage division. You can compute this will be 1 by 4 volts, right? Simple voltage division. Okay, so obviously flux in the inductor will increase, and same thing will happen. Just this time, this is going from 1 by 4 to 1 by 2. Okay, so this analysis will be totally same. This analysis will be totally same, right? Nothing different. This analysis won't be different. Okay, here I will have 1 volts. Here I will have 1 volts. So this analysis will be completely same. So obviously this time, right, it will go from 1 by 4 to 1 by 2. So the curve will look something like this. Okay, it will be exponential, but it will go from 1 by 4 to 1 by 2. And what will be my expression for voltage? It will be 1 by 2 1 plus this will be what this expression will be 1 by 2 1 plus, what was the previous expression? Minus 2. Yeah, I made a mistake over here. This should be plus, right? This should be plus, this should not be minus. If it is plus, then only this will be 3 by 4 and this will be minus here. Okay, this should be plus, this should be minus here. Minus 1 by 2 e raised to power minus t upon tau. Now case 5 is when r it is equals to r by 2. So both of them are same. Okay, so if it is if both of them are same, then obviously what will happen? Just this case, right? Here I'll just copy this case. We'll just copy this. Everything will be same, just the voltages, initial voltages will be same across the inductors, 1 by 2 and 1 by 2. This will be 1 by 2 and not 3 by 4. So this will be 1 by 2, this will be 1 by 2, this will be 1 by 2, this will be this will be 1 by 2. So yeah, the initial voltage will be 1 by 2, and obviously it will also settle to what? It will settle to 1 by 2 itself, because this will be same, right? This will be same, this will never change, because this depends on the inductance, not on the resistors. So this will be always same. So if this is the same, then what will happen over here is that it will suddenly rise up to 1 by 2 and it will remain at that point of time. Nothing will change in the circuit. Okay, it will reach steady state instantly at t equals to 0. So it will reach steady state instantly at t equals to 0. It will rise up to 1 by 2 and then again it will remain at that 1 by 2 volts. Okay, 1 by 2 volts. So VO of t will always be 1 by 2 volts. Now what about the poles and zeros of the circuit? So poles and zeros are very simple. So what is my poles? So poles is again negative of inverse of magnitude of time constant, which is simply minus R1 parallel with R2 divided by L1 parallel with L2. Okay, so that you can do. What about zeros now? So about zeros, I will copy the circuit. Where is the circuit? If I can find out the circuit here. Okay, so for zero, either we have to break the link or short the output. Can you short the output? No. At s equals to 0, yes, s equals to 0 we can short, but this is also going to skew, so that is not a valid short the output, right? Not a valid 0. Okay, but can we make this infinity? Yes, right, we can make this infinity if SL1 equals to minus R1. So first one is break the link. Okay, first one is break the link. So obviously this one will be what? This one will be SZ will be equals to just hold on, LSZ SZ into L will be equals to minus R. L1 equals to minus R1. So SZ will be equals to minus R1 by L1. And can I short the, like we have got already 1 0, right? And we know this is a single order circuit, so obviously we won't compute for another 0, because for real systems number of poles will always be greater than or equal to 0. Zeros can never be more than poles, because if zeros is greater than high frequency gain will be infinite, and getting infinite gain is not possible for real life systems, right? That's why. So anyways, I will compute here, short the output. If I short the output, what will happen at s equals to 0? S equal to 0, this is the Z2, right? This is my Z2. Z2 is going to 0. But the problem is my Z1 is also going to 0. Z1 is also going to 0. So not valid 0. Not valid 0. Okay, not a valid 0. So this is the case. Now let's compute the DC. Like basically that is the S equal to 0. So at S equal to 0, this will give low impedance, this will give low impedance. Both of them will dominate as R1 and R2. So the DC gain will be L2, L1. This is VI and this is VO. So basically R1 and R2 we will ignore. So S equals to 0. So VO of S will be, I'm computing the low frequency again, it will be equals to L2 by L1 plus L2 into VI of S. So VO over VS, VI of S will be L2 over L1 plus L2. Okay, so this is my DC gain basically. Now how will my transfer function look? It will be A times the 0. So A is L1 by L1 plus L2 into what? Into my 0. 0 is where? 0 is R1 by L1. 0 is R1 by L1. So I can write it like this as L1 R1 divided by, what is my pole? Pole is at omega p, so I will write this as omega p only, or you can write it in full form. This will be L1 parallel with L2 divided by R1 parallel with R2. Okay, this will depend on different cases. Okay, so like, okay, can you compute the high frequency gain? So because this is important for computing the Bode plot. So what is the high frequency gain? High frequency gain, if I draw my circuit, only what will happen at high frequency, this will have very high impedance. High frequency, this will have very high impedance. So both of this will give very high impedance and they are in parallel. So this R1 and R2 will give low impedance. So R1 and R2 will dominate now instead of L1 and L2. So R1 and R2 dominates. So obviously I can write, this is my VO. It's not T, this is S. So VO of S equals to VI of S into R2 by R1 plus R2. Okay, so this is what my VO over VI of S is. VO of S by VI of S equals to R2 by R1 plus S. This is the high frequency gain, right? This is the high frequency gain. So if my S is tending to 0, so the coefficient L by R1 and this, right, this will simplify to this, because else will get cancelled and this will be simplified to this, because L1 by L1 plus L2 is here, so they will get cancelled with this, and L1 is here anyway. So okay, sorry, this is not L1, this is L2, right? This is L2, and this will be simplified to this. Okay, so all of it depends, right? So if I have case 1, my L was always equal, right? Case 1 is what? Case 1 is basically L1 equals to L2 equals to R2. L1 equals to L2 equals to L. But in case 1, my R1 equals to R by 4 and R2 equals to 3R by 4. Okay. Now if I compute the ratio, that is L1 by R1, which is 4 itself. 4 L by R, and if I compute the ratio of L2 by R2, which is 4L by 3R, okay, which is 4L by 3R. That means my L1 by R1 is greater than L2 by R2. L1 by R1 is greater than L2 by L2. Basically, this means like time constant of that particular Z1 is greater than time constant at Z2. But why is this important? Why is this important? If I see carefully, that means L1 by L2 is greater than R1 by R2. So if L1 by L2 is greater than R1 by R2, what is my DC gain? What is my DC gain? DC gain is L2 divided by L1 plus L2. Now if I divide by L2 on numerator and denominator, this will become L1 by L2 plus 1. So it is talking about L1 by L2 is greater. So this is this expression H of 0, and let's talk about the high frequency gain. So at high frequency, this becomes R2 divided by R1 plus R2. So now if I divide R2 on both sides, this will be 1 by R1 by R2 plus 1. Now basically what I'm doing this comparison. So L1 by L2 is greater than R1 by R2. So the denominator of H of 0 is higher than denominator of H of infinity. So if this denominator is more, so overall this will be lower. So DC gain will be lower than the high frequency gain. That is what we conclude from this analysis. DC gain is lower than the high frequency gain. Okay, so high frequency gain will be higher for case 1. For case 2, what will happen? If you do similar analysis, case 2, this was 3R by 4, this was simply R by 4. So this became 4 by 3R and this became 4L by R. So this time the opposite is happening, that my L2 by R2 is greater than L1 by R1. So my L1 by L2 is lower than my R1 by R2. So basically this, right, this is more than this. So if this is more, so high frequency gain is lower than low frequency gain. So H of 0 will be greater than H of infinity. And for case 3, what will happen? For case 3, basically both of them are same only, right? For case 3, this was R by 2, this was also R by 2. This was 2, this was equal, this was also equal, and this will be also equal. So high frequency and low frequency gain will be equal. Basically my Bode plot also will not change, as my time response is not changing. Bode plot will also not change. So obviously if I plot the Bode plot for case 1, that is when my L1 by R1 is greater than L2 by R2, what is happening this time, right? This time first case was my DC gain was lower than the high frequency gain. Like why we did this much analysis? To understand that how we start our Bode plot, right? How will we start our Bode plot? So basically if my high frequency gain is higher than my low frequency gain, so initially start lower, then what happens is that my high frequency gain is higher, right? So obviously what will happen, if my high frequency gain is more, that means at high frequency I will be somewhere here, okay, and low frequency I will be somewhere here. So what does this type of shape mean? What does this type of shape mean? This type of shape means that my pole will occur later than 0. So 0 will occur first, 0 will occur first, and pole will occur later, okay, as my high frequency gain is higher than low frequency gain. And from where I will start? So anyways, what I know, what is the low frequency gain? L2 by L1 plus L2, which is again lower than 1, because L1 plus L2 will always be greater than L2. And what is my high frequency gain? High frequency gain also is also R2 by R1 plus R2. Again, it is lower than 1. So anyways, I will lie in the lower half of Bode plot, right? Negative side, not on the positive side, because it is always lower than 1. So I will start from somewhere low, because my low frequency gain is lower than the high frequency gain. Let me just check once if I did the low frequency gain is lower than the high frequency gain. So I will start from somewhere here, then I will get a 0 which will make my gain higher, then again I will get a pole okay, which will make my slope 0. So this is why we did the analysis, to make everything simpler, to plot the Bode plot, right? To plot the Bode plot. This is omega p, this is omega z, and what is this? What is this? This is 20 into what? 20 log of h of 0, which is L2 upon L1 plus L2. And this is what? This is 20 log of h of infinity. So yeah, this will be the case for the first one. Let me just check once if I have done everything correctly or not. So this, right, for the first case, my L1 by L2 is greater than R1, so this will be lower than, okay, yeah, fine. Yeah, this is fine. So this will be the case, right? This will be the first case. My pole will occur first, because if my pole occurs first, my 0 will occur first and my pole will occur later, because 0 will have a slope of plus 20 dB per decade, hence it will increase the gain, and then my pole will occur, which will make the gain constant there, because overall slope will become 0 dB per decade. So here the slope initially obviously is 0 dB per decade, okay, and the pole here becomes 20 dB per decade, and here it becomes again 0 dB per decade. Now if we do it for, like, if I want to compute the phase, right? If I want to compute the phase, what will happen? My 0 is less than omega p. If my 0 is less than omega p, so initially like the graph, you can confirm, like we have done so many examples where my 0 is less than, so when my 0 is coming first, so obviously the effect of 0 will come first, then just after that the effect of pole will come, which will make the slope again 0, okay, then the effect of 0 will go away, so pole will remain, so again it will due to the pole, the slope will be minus 45 degree per decade, then the effect of pole will also go away, right? So this is how it will look. So the shape will be like this. So first here, this is omega z by 10, so first we get the effect of 0, then I get the effect of pole, then I get the effect of, like, then obviously there is in between, there is 0, there is pole, and here, right, the effect of 0 goes away, this is 10z omega, and here the effect of pole also goes away. What is this value? I don't know. What is this value? I don't know, right? So this is how your Bode phase plot will look. And for case 2, what is happening? My L1 by L2, my L1 by R1 is less than the L2 by R2, right? L2 by R2 is greater. So this time the high frequency gain is less than the low frequency gain. The low frequency gain is greater than the high frequency gain. So this time I will start above and end bottom. So obviously I have to go something like this. Okay. For this, my pole has to be earlier than the 0, because that will give me only minus 20 dB per decade gain. So omega p will be less than omega z. So I will start here. My slope will be like this, and this will be like this. This is omega p, this is omega z, and I will start from 20 log of h of 0 and end to 20 log of h of infinity. Okay, so this will be the case. So how will my phase plot look? Again, the phase plot this time, as pole is coming first, so effect of pole will come first, so it will be somewhat like this. Effect of pole will come first, so I will get minus 45 degree first, then it will be like this. So here this will be omega p by 10, effect of pole comes first, then this is omega z by 10, then this is omega p, then this is 10 omega p. Here in between I had omega z as well, then this is 10 omega z, right? 10 omega z. Effect of 0 is also gone. So yeah, this is how your Bode phase plot will look for the case 2. So now for the case 3, obviously everything is same. L1 by R1 equals to L2 by R2. So L2 by R2 is equals to L2 by R2. So if everything is same and it is equals to what? Half. It becomes half. H of 0 is also half. H of infinity is also half. It becomes simply half, and VO is equals to VI by 2. So basically it is what? It will be always negative constant. Obviously there will be pole 0 cancellation, so there won't be any pole or 0. Okay, so it will be equals to 20 log of 2 in minus sign. Okay, as it is half. Simple as that. There is pole 0 cancellation over it, and phase will always be 0. Okay, it is half, right? There is no phase difference between input and output. Okay, so this is about this circuit. Okay, this is about the analysis of the circuit, and no one will tell you the analysis of the circuit, trust me, right? So no one will analyze the circuits. Okay, and in interviews also this may not come. Okay, this much difficulty level, but if you know this much difficulty level, you can solve anything. You can literally solve anything. Okay, so this much body plot analysis and this much phase plot analysis like will help you only. So let's solve the second circuit. This is the second circuit. Here again I have two inductors and two resistors. But the difference is here I had inductor and resistor, but here also I didn't have a resistor that time, but this time I have resistor. But obviously I can see all of these are contained in series, so the two inductors will become L1 plus L2 and the two resistors will become R1 plus R2. So overall number of independent energy storing elements is only 1. Okay, so order will be 1. Okay, so it will give exponential response, and for us to simplify everything, what we'll do, we'll assume L1 equals to L2 equals to L and R1 equals to R2 equals to R. Okay, L1 equals to L2 equals to L, R1 equals to R2 equals to R. So what will be my tau? So overall, like my L equivalent is what? Both of them are in series. Right? If I connect this source, L1 is in series with L2, so it will be 2L, and R equivalent will be 2R. Okay, so my tau will be 2L by R, 2L by 2R, which will be L by R itself. Okay, which will be L by R itself, right? So if it is L by R, tau is L by R, that is fine. Now let's intuitively understand what is actually happening in the circuit. Okay, so what you can do, obviously I assumed here to compute the tau, but we will take three cases to understand what is actually happening. So first case is when this is 3R by 4 and R by 4. So this case is in the previous case also, if you assume L1 equals to L2 and R1 equals to R2, time constant will be simply tau by 2. Okay, but like there won't be any time constant because it will become a zeroth order circuit. So that is one thing. So now here what is happening, if I give a unit step, this and this will be open circuit, this and this will be this and this will be open circuit, and they will provide zero current. So obviously the voltage will get divided half and half. It will be positive, so inductor current will increase, but then there will be some drop across this and this. So then the rate at which inductor current was increasing, it will reduce. So the voltage across these inductors will also reduce. So rate will reduce slowly. The voltage will try to go towards 0, and if it goes towards 0, then obviously that's fine. There will be some current flowing, that is 1 by R1 plus R2. So that is the simple analysis, right? So but there will be one thing, initially what will be the voltage, and from initial voltage to where it will go. Okay, so that is one important thing. So in this circuit also we're mainly analyzing the voltage current you try to analyze. So for this case, right, what is the initial like initially obviously the flux is 0, IL 0 minus is 0. Okay, so if it is 0, then if I just draw the circuit here, this will be open circuit, this will be open circuit. Okay, so this resistors will be gone and the voltage will get divided between these two, 1 by 2 volts and 1 by 2 volts. Okay, so this will become what? Just hold on a second. So VL of 0 plus is 1 by 2 volts, which is finite and greater than 0, which is finite and greater than 0. Okay, so finite and greater than 0. Next, what will happen? Next, basically as it is finite, so obviously it won't changes current instantaneously. So my IL of 0 plus will also be 0 amperes. Then slowly the drop will occur across this, and the current will also try to current will increase, but the rate at which the current is increasing will reduce. Okay, so what is my VO of 0 plus? VO of 0 plus will be VL of 0 plus, because the current is 0, the drop across is R2 is 0. So overall VO of 0 plus will be this inductor voltage itself. Okay, at steady state, what is happening? Steady state, the inductors will become short. Okay, as the rate at which the current is flowing will reduce and will go to 0, hence inductor will become short. This will be R2. Okay, this is at t equals to infinity. So if it is at t equals to infinity, this is 1 volts. Actually, I should have mentioned this is 1 volts. Okay, so as this is 1 volts, so obviously my VO will be R2 by R1 plus R2 by R1 plus R2. So what will this be? So this right, this will be simply VO of, this will be R2 by R1 plus, so this is VO of infinity. This is R2 by R1 plus R2. So this is R2 by R1 plus R2. So it all depends upon these values, right? So like initial condition will always be same because it depends on L, but the final conditions, right, will change. Final conditions will change. So here my R2 is R by 4 and R1 is 3R by 4. So the bottom will be R only. Okay, bottom will be R, but R2 is R by 4. So this will be 1 by 4 volts. Okay, so starting it went from half to 1 by 4, so it is reducing. Okay, it is reducing. You can plot the current waveform by yourself. That is the homework for you. From 1 by 2 it is going to 1 by 4 volts. So how will my equation look like? So my VO of t will look like, initially I had 1 by 2 volts. So initially I had 1 by 2 volts. So it will be, I'm just thinking how will my equation look like. If I write 1 plus e raised to power minus t upon tau, t equal to 0, this is becoming 4. So if I write this as 4, t equal to infinity, yeah, this is fine, right? So this is 1 by 4 into 1 plus e raised to power minus t upon tau. So this will be my equation of voltage for case 1. For case 2, what will happen? For case 2, obviously the difference is, basically this time my R1 is lower than the R2. So like R2 is higher. Previously R1 was higher. So everything will be same, right? This analysis will be exactly the same thing. Nothing will change. Okay, nothing will change. IL of 0 minus is 0 itself, so flux is obviously 0. How will I paste? Okay, this is bad. This can go here, and this can go here. So this is at t equals to 0 itself, which will be same analysis, and t equals to infinity will also be same analysis. Just my values of R1 and R2 have been changed. So this time my R2 is 3R by 4 and not r by 4, so this will be 3 by 4. So this time it will go from 1 by 2 to 3 by 4, so it will increase this time, right? It will increase. So it will go something like this. So this will be 1 by 2 to 3 by 4. So how will my equation look? So my equation will obviously, this will be 3 by 4 itself, this will be 1, and initially I had half, right? So how will my equation look? So if I just subtract, okay, what should I subtract to this so that it becomes at t equals to 0, it becomes 1 by 2. So at the top I need to have, so I need to get, what should I multiply so that I can get 1 by 2? So this is 2, so this is, I need to get 2 by 3, right? So 1 minus 1 by 3 will yield me 2 by 3. So this will be 1 by 3 e raised to power minus t upon tau. Else you can do with that formula, initial plus v of, like v of infinity plus v of 0 plus minus v of infinity multiplied in bracket multiplied into e raised to power minus t upon tau. Like that also you can do. Okay, this will be v of t. And obviously for the case 3, when both of them are equal, everything will almost be same, right? Everything will almost be same. Okay, like it will settle instantaneously. So the voltage will be half across both of them. Okay, then whatever current it gets, it settles instantaneously. So it goes to half voltage and it remains at half voltage. What do I mean by that? So if I just copy this analysis, and if I just copy this analysis, like v of infinity and v of 0 plus, both of them are same. Obviously it doesn't change after that, it remains same, right? This will be simply r by 2, this will be r, right? And this will be 2r. Now what have I done? Okay, both of them I have picked as r, so this will be 2r and r, so this will be 1 by 2 volts. Okay, so obviously it will instantaneously rise up to 1 by 2 volts and it will remain at that. Okay, so like this doesn't have any time constant obviously, so v of t you can write as 1 by 2 volts. Okay, so for this, right, I want to give you the homework as impulse response. So you try to do the impulse response by yourself, because you have seen so many impulse responses. So this you try as your homework. I will directly move on to poles and zeros. So like what will be the poles and zeros? So poles is very simple, right? Poles is again very simple. It is negative of time constant for first order, negative of time constant, sorry for the burping. So it will be minus of what, like L1 plus L2 by L2 plus L1. So this will be R1 plus R2 divided by L1 plus L2. Okay, so this will be the case. Now what about the zeros? So can I break the link? No, right? At s equals to infinity only this can open circuit, but this also is been open circuit, and anyways that is not finite, so no, can't break the link. But I can simply short this, right? SL2 equals to minus R2, that can make this impedance 0, so I can short the output. So break the link. Break the link. No. Short the output. Short the output will be what? SL2 equals to minus of R2. So SZ, so this is also finite, which is minus R2 by L2, and in this case, right, this is not going to 0 as well. So this is not going to 0, so this will be my 0. Okay, and what about my DC gain? So DC gain, obviously this will provide 0 impedance and this will provide 0 impedance. So simply my circuit will become like this. So VO of S will be equals to VI by VI into R2 by R1 plus R2. Similar analysis just like the previous one, just it is flipped. It is flipped, right? So VO of S divided by VI of S equals to R2 divided by R1 plus R2. This is my DC again. So right now I can write my transfer function, right? I can write my transfer function. But before that, obviously I want to compute the high frequency again. So high frequency again, what will happen? The L1 and L2 will provide high impedance with respect to this R1 and R2. Okay, this is at S equals to 0. This is at S equals to infinity. This is gone. Okay, they will gone because L1 and L2 will provide high impedance. Okay, so my VO of S will be equals to VI of S into L2 upon L1 plus L2. Okay, so VO of S by VI of S is L2 by L1 plus L2. Okay, so this is my high frequency gain. Why am I doing all this? Basically for plotting the Bode plot again, right? So like from here itself I can write my transfer function. Okay, what will be my transfer function? Transfer function will be DC gain R2 by R1 plus R2 into 0. 0 is SL. This time 0 is different. This is SL2 1 plus SL2 by R2 divided by one plus S L1 plus L2 divided by R1 plus R2. Okay, so you just compute like at S tending to infinity, what will happen? This and this will get cancelled out, and this and this will get cancelled out. Only L2 upon L1 plus L2 will remain, and that is what we get over here. So you can cross verify, right? So again, right, there will be 3 cases this time. Like I will just copy those things. Okay, just that they will be flipped because h of 0 and h of infinity is flipped. So where are the cases? Here were the cases, right? Yeah, here are the cases. I'll just copy these 3. Okay, so obviously L1 equals to L2 equals to L, but for the first case my L1 by R1 is greater than L2 by R2. So basically this time, right, these things will be flipped. So here this will be h of 0 and this will be h of infinity. This will be h of 0, h of infinity. Okay, so what was the first case? First case was when my R2 was greater, right? R2 was greater. So if my R2 is greater, if I just go back here, this right, if I just keep this R by 2, that would be more consistent. This will be R by 2. This will be also R by 2. So this will be overall R by 2 by R itself, which will be 1 by 2 itself. So what was the case 1? Case 1 was, okay, R1 was 3R by 4 and R2 was R by 4. This is, okay, R1 was 3R by 4 and R2 was R by 4. So this one was the case 1, right? So this I can interchange as case 1. Okay, just थोड़ा सा कलाकारी कर रहा हूँ, इसको मैं पहले कर देता हूँ. I will keep this first and keep this as second, and what I will do is make this case 2, and okay, this is fine. And just write the h of 0 will change, right? H of 0 will change to this. H of 0 will be L2 by L1 plus L2. This will be this, and h of infinity will be this and this. So what will happen? Everything will be same, right? Everything will be same. Just the difference will be this will flip. This will flip. Okay, you can compute for yourself. This will flip, and here also this will flip, right? This will flip. So yeah, and this will be same. This will be exactly same, right? In the previous case, have I deleted this? Just hold on. Let me go back. Okay, this will be equal, right? I've forgotten to write this. Yeah. So everything will be same. Just write if I just copy these cases, right, I'll just copy these because I want to save time as well. They will be flipped, everything will be same, they will be flipped, exactly, they will be flipped. So let me just paste this over here. So this time, right, my case 1 will become case 2, so this will go there. Here, okay, this will become case 2 and this will become case 1. So this time my L1 by R1 is less than L2 by R2, yeah, and this is greater than. So border plot will be like this, right? Why will it be like this? Because my h of 0 will be greater than h of infinity. H of 0, okay, case 1 h of 0 is less than h of infinity, sorry, okay. Oh, but this is different, right? Okay, so okay, this won't change, sorry, we had to, okay, this won't change. What we to do is to take this. That's what happens when you try to do all this, right? When you try to save time, when you try to take shortcuts, these things happen. So this one will be case 1 anyways, but the difference will be L2 by R2 will be greater than L2 by L1 by R2, yeah, L2 by R2 will be greater than L1 by R1, and L1 by R1 will be greater than this will be case 2. Okay, so in case 1 what is happening? Case 1, h of 0 is less than h of infinity. So if h of 0 is less than h of infinity, so h of infinity is higher, so obviously this will finish higher, and obviously my 0 will be come earlier. All the reasons I've explained in the previous case. Okay, next, like phase plot, as 0 is coming earlier, so at the starting I will get more positive phase, then a pole will come which will reduce the phase, then it will go to 0. Okay, it will go to 0. Then again here, right, here my h of 0 is greater than h of infinity, so I will start with higher value, then it will go to lower value, then again it will steady state. Obviously I will have pole earlier than 0 this time. The reasons I've explained in the previous example. And here also, as pole is coming earlier, so I will get some negative phase at the starting, then 0 effect will come, it will negate the effect of pole, then again effect of pole will go away, so 0 will increase the angle, then effect of 0 will also go away, right? So here, right, this is just the same case, which is 20 log minus 20 log 2, which is basically like constant value, which is basically constant value, right? H of 0, which is basically constant value. So the phase will be 0 itself, so I can delete all this. So we will solve the next circuit. I will just take a break and then I will start with the next circuit. So what is this circuit? This circuit is like a bridge circuit. So like first of all, understanding that this is a first order circuit will be very difficult. There needs to be a particular condition that needs to be satisfied so that this is a first order circuit, and that condition is already present over here. Okay, basically the ratio L by R should be equals to L by R. Okay, these in ratio and this ratio should be same. How is it possible? So first of all, let me copy this second. This is already here, paste it. So I will name the terminals. So I have already solved this type of question in my channel. This will be 1, 2, and then 3 and 4. Okay, 1, 2, 3 and 4. Now let's name these terminals, right? Let's name this as R1, this as L1, this as L2, this as R2. Okay, so if I name this, now if I redraw this circuit, so at first glance it may seem that this L1 and L2 are independent of each other, which is true. They are independent energy storing element, but if certain condition gets satisfied, so this one will become first order circuit. So let me draw the circuit here. So what I will do, I will keep here 1 and 3 as my input terminals, and 2 and 4 as my output terminals. So 1 and 3, so 1 will come over here, one and 3 as my input terminals. Okay, so this is my input terminal. So this is basically Vi, so which I will short, right? Which I will short because for checking the order I need to short the independent sources. And here, right, between 1 and 2 I have a R1. So I will write here between 1 and 2 I have a R1. This is 2. And between 2 and 3 what do I have? Between 2 and 3 I have L2, right? Between 2 and 3 I have L2. So I will draw here. This is not resistor. L2. Now between 1 and 4 what do I have? Between 1 and 4 I have L1. And between, okay, this is 4. Between 4 and 3 I have R2. This is 2 and 4, right? So this is my output terminal basically. So what is this? This is like a bridge circuit. This is like a bridge circuit, right? Now as these two are in series, these two elements are in series, what I want to do, I want to flip this, right? I just don't want to compute the output voltage right now. For now I'm interested in something else, right? I'm interested in checking the order. So what I will do, I will just, as these are in series, right, I will just change the position of these two. Okay, so this and this will be, this will be R2 and this will be, sorry, this will be L1, right? So basically like they are in series, right? As they are in series, as this is open terminal, so I can swap the positions of these two, right? So I'm not concerned about the output for now. I'm just concerned about the order of the circuit. So now what condition I can make? I can make that bridge condition, right? What is that condition? That opposite end impedances multiplication should be equal for it to be balanced bridge. So if the bridge is balanced, so the potential here and here will be same itself, right? Potential here and here will be same. So basically it has to be R1 into SL1 equals to R2 into SL2. Yeah, am I correct? Yes. So basically L1 by L2 should be equals to R1, hold on a second, R2 by R1, and it is obviously frequency independent. So like basically we can make it some constant K, and here, right, we're making everything equal. L1 equals to L2 equals to L, and R1 equals to R2 equals to R. Okay, so then what will happen? Then basically these two terminals, right, these two terminals will be same. Hence, as these two terminals will be same, L1 will be parallel with L2 and R1 will be parallel with R2. So basically my L equivalent will become L1 parallel with L2, which is L by 2, as L1 equals to L2, and R equivalent equals to R1 parallel with R2 equals to R by 2. Okay, so this will be the case. So obviously here number of independent energy storing element will be 1 only, because both L's are in parallel. Okay, so obviously exponential, like a response will be exponential. Okay, so tau we have already computed. What is tau? Tau is L equivalent upon R equivalent, which will be simply L by R. Okay, tau will be L by R. Okay, so now let's go to the circuit. So now I will solve the circuit, as I have established that it will be a first order circuit. Now I will solve using this circuit and not using this circuit. You can solve using this circuit also, but it is easier for me to compute here, right? It will be easier for me to compute here. So what will be here? So here I have a voltage Vi, right? At this note I am giving in Vi. Just reduce the size. So what will be the case? Obviously here if I am giving unit step, what will happen? Initially inductors have no charge, so they will be open circuited. So is there any path through here? So this 1 volts, right, this 1 volts overall will come across this L2, and this 1 volts will overall come across as L1. So both of them will be 1 volt itself. So both of the inductors will have 1 volts, and it will be positive, hence the current slowly will increase. Now if the current slowly increases, what will happen? The voltage drop across this will increase. So voltage across the inductor will reduce. Still it is positive, but it will reduce. As it reduces, what will happen? The rate of change of current will reduce. Still it is positive, but it will reduce, hence the current slowly it will increase, but the rate will decrease, and at steady state this will become short circuit, this will become short circuit. So overall whole voltage will be here, and what will be the current? As this is also R and that is also R, so all of these are R, right? R and L. So the current through here will be 1 by R, and current through here also will be 1 by R. Basically these two are basically two parallel circuits. I am computing the voltage between these two nodes. Okay, computing the voltage between these two nodes. So basically what will happen? First, through here, what will be the potential? I will compute here. The potential I will compute here, and then subtract these two at 0 plus, and at infinity also I will do the same and subtract these two. Then I will directly write the expression. Okay, so this one you have to do it like this. You can't just simply intuitively say what will happen. I just told you what will happen at the stage that this will become short circuit, this will become short circuit, 1 by R current will flow, right? But directly saying the expression of the voltage will be difficult. We have to solve the circuit. So let me draw for t equals to 0 plus. So I will just copy this, actually just copy this. Okay, so here, right, the full potential will come, that is plus minus 1 volts, and here plus minus 1 volts. So this will be 0 volts, right? This will be 0 volts, and this will be also 0 volts, as 0 current is flowing. Okay, this is at t equals to 0 plus. So obviously initial flux across the inductor is 0. Initial flux across the inductor is 0. Then initial current across the inductor obviously is 0, IL 0 minus, and it will be equals to my IL 0 plus. Okay, IL 0 plus, as my voltage VL 0 plus is only 1 volt, which is greater than 0. Also it is finite. So as it is finite, it will be like current will be equals to 0 only. Okay, so flux in the inductor will increase. So what will be the potential here? What will be the potential of VO? So you can apply KVL, right? How can you apply KVL? Either you can apply KVL here. So if I apply KVL here, what will happen? Minus 1 volts, minus 1 plus VO. Okay, then this, right? What is the voltage across this? 0 volts. So this is anyway 0 plus 0 equals to 0. So VO 0 plus is what? VO 0 plus is 1. Okay, VO 0 plus equals to 1 volts. VO 0 plus equals to 1 volts. Okay, so what is happening at infinity? At infinity, if I paste this circuit again, this will be short circuit and this will be short circuit, right? So this is short circuit, this is short circuit. So basically here, right, the whole potential will come here. So this will be plus minus 1 volts this time. This will be plus minus 1 volts, right? I'm not concerned for the current. So what I can do right now, I can put a KVL over on this side. You can do either way. You can do this or this. Okay, so this is at t equals to infinity. So my VL, so basically if I apply KVL in this loop, right, so minus VO minus 1 equals to 0. So VO equals to VO of infinity equals to minus 1 volt. So VO of infinity equals to minus 1 volts. So I'm not concerned about the like inductor voltage. So I will directly plot it. So it is going from plus 1 to minus 1, right? That is more important. It is going from plus 1 to minus 1. So from plus 1 to minus 1, obviously exponentially. Minus 1 volts, and this will reach here in 4 tau on time, obviously 4 tau time. So what is my VO of t? VO of t is so initial voltage was 1 volts and final was in minus 1. So minus 1 plus 1 minus of minus 1 e raised to power minus t upon tau. So this is minus 1 plus 2 e raised to power minus t upon tau. Okay, so this will be my equation for this particular plot. Okay, so now let's do the impulse response. Impulse response will almost be same. So let me draw the circuit over here, and this time there will be impulse, right? So if an impulse is coming over here, so initially the whole impulse voltage will be across these two inductors. So they will be charged to each 1 by L of current. So this will be totally energized to 1 by L. This will be totally energized to 1 by L. Then this will become short suddenly. So if this becomes short suddenly, what will happen? This inductor will discharge through this path, and this inductor will also discharge through this path. Okay, so this won't choose this path. Why? Because there is resistance over here. It won't choose this path, right? This will choose only this short circuit path. Okay, both of them will discharge, both of them will go to 0. So at steady state, obviously this will go to 0. Okay, but initially what will be the voltage? We have to compute with the help of KVL, because both of them will be replaced with the current source of 1 by L. As impulse voltage has been applied, the energy will change instantaneously, and they will be charged to 1 by L of current, each of them. Flux will change instantaneously. So obviously initial flux is 0. Okay, hence IL0 minus is 0, but after that what is happening? Oops. This is okay, I will not replace that now. I will just open circuit them, right? Because initially they are uncharged, so they will be open circuit. This is the circuit at t equals to 0, not 0 plus. So a impulse voltage has been applied. So here I have applied a impulse voltage, right? So this, as the current through this is 0, so overall this impulse voltage will come across these two inductors. They are in parallel, right? So this is delta of t, and this is also delta of t. Okay, so now what I can say is that impulse voltage has been applied across this. So VL0 equals to delta of t, right? Hence this is infinite, hence not equals to IL of 0 plus. IL 0 plus will be changed to what? IL of 0 plus will be simply 1 by L integration of delta of t dt equals to 1 by L amps of current, right? 1 by L amps of current. Okay, so flux will change instantaneously. So let me just draw the circuit again. Okay, where did I go? So this time they will be replaced with current sources. 1 by L and 1 by L, right? So now we can compute the voltage. So how can we compute the voltage? Like I don't know the voltages of these two current sources. They are unknown to me, right? I don't know the voltage. So I should take a different path, and obviously this impulse will also go away, right? This impulse will also go away, as like impulse only remains for t equals to 0. At t equals 0 plus it is 0. so obviously it will get short circuited. It will be short circuited, hence at t equals to 0 plus they will go away. Okay, and now what path should I take? I should take this part. I know the current through here. What is the current through here? 1 by L, because this is in series, and I know the current through here, that is, which is 1 by L. So I can take this path, right? I can take this path, okay, where no current sources are involved. So whenever you are taking KVL, you have to take care that there is no current source, because the voltage across current source is unknown to me. Okay, so what is the drop across this? The drop across this is what? Current is flowing like this, so it will be, let me take a different color, plus minus R by L. This also current is flowing like this, so drop will be plus minus R by L. Okay, so if I take this path, right, if I take this path, what will I get? This will be minus VO of 0 plus minus R by L, then minus R by L equals to 0. I completed a loop, right? This minus R by L, minus R by L, and this loop has been completed. So my VO of 0 plus is basically minus 2 R by L, okay, and which is okay, because this side obviously it will be here, right? The voltage across this inductor will be minus R by L, and voltage across this inductor will also be minus R by L, because the inductor has to reduce, right? I mean the discharge, right? Inductor has to discharge, the current has to reduce, so obviously VL has to be negative, hence DIL by dt will be negative, hence the current will reduce instead of increasing. Okay, this is a source free network, it will go to 0 anyways, right? So at 0 plus this is this. Now what about the infinity? What about infinity? So at infinity obviously everything will be gone, everything will be short circuited, so this whole thing will become source free network. So this will be 0, this will be 0, okay, this will be 0, this will be 0, everything will be short circuited. So if I go current through here will also be 0, so VO will also be 0 volts, right? V of infinity will also be 0 volts. Okay, so let me plot it. So it is going from minus 2 by R, minus 2 R by L to 0. It will be something like this. So this will be photo, this will be photo. Okay, so yeah, this will be the answer to this question. Basically this will be the plot. Now let's go for the Bode gain and phase plot. So plotting the Bode gain and phase plot for this will be difficult. Why will it be difficult? Because like you cannot do it in the standard format, because like with break the link, short the circuit, you cannot do it, because this, right, this is not in the standard format, this is not in Z1 Z2 format, right? This is in some other format, so we have to take help of the Laplace itself. How can I take help? I can take help of the superposition and Laplace. So I will compute the voltage at this node 2 and node 4, and I will subtract those two. So what is V2? V2 is simply voltage division, right? If I do simple voltage division, this is like a simple series circuit, so this will be simply Vi of S into SL by R plus SL. Okay, V4 of S will be Vi of S into R by R plus SL. Okay, R by R plus SL. So if I subtract, like, what will be my VO of S? VO of S will be V2 minus V4, which is equals to Vi, take it as common, it will be SL, like denominator is same, so this will be R and this will be SL plus R. So what I can do, I can divide the numerator denominator by R, okay, to make it some format. So VO of S by Vi of S will be SL by R minus 1 divided by SL by R plus 1. Okay, so it will be SL by R minus 1 divided by SL by R plus 1. So this will be basically a non-minimum phase system. Non-minimum phase system. Why is it called non-minimum phase system? All these things I have explained in my control systems lectures. You can go and watch those lectures, right, in playlist. As the poles, like one of the 0 is lying on the right hand side, this will be a non-minimum phase system. So obviously computing the phase will be difficult. What will be the gain? Gain is magnitude of g omega, right? Now if I compute the magnitude of g omega, this will be 1. Actually, why? Because this will be equals to under root 1 plus omega L square divided by 1 plus, again this will be omega L by R square, right? Here there is a minus inside, so as we are squaring it, it will become plus itself, right? So this will be whole square, so this will be equals to 1. And what about the phase? What about the phase? So phase, right, if you observe carefully, h of g omega, so the phase contribution due to this will be what? Like this is lying in what? Which quadrant? This is lying in the what? In the second quadrant. Why is this lying in the second quadrant? Why is this lying in the second quadrant? This is plus comma plus, and this is minus comma plus, because this is known as the x and this is known as the y component. The x component is negative, y component is positive, so this is in the second quadrant. And at second quadrant, what is the angle? Angle is 180 minus theta. Okay, all these things I have explained previously, I won't explain here. So angle will be 180 degrees minus theta due to the 0. So it is basically, what is this? What is theta? Theta is tan inverse y by x, tan inverse L by R, tan inverse omega L by R, and this is simply in the first quadrant, so this will be theta itself, and minus, as this is in the denominator, so minus tan inverse omega L by R, so this will be equals to 180 minus 2 tan inverse, okay, this is inverse actually, omega L by R. Okay, so this will be my angle formula. This will be my angle formula. Okay, so basically now we can plot the Bode gain and phase plot. Gain is always 1, so Bode gain plot is simple only as a h of g omega. What is happening? Okay, this is some other actually. Okay, something has been gone wrong with this, so I will just use this and I will copy. This I can reduce the size, right? So Bode gain plot will be this only, constant only, right? So as my h of magnitude of h of j omega is equals to 1.0. And here what will be the Bode phase plot? Basically what will happen is phase initially at omega equals to 0, this is 180, and I have two poles at omega equals to r by L, right? Omega p is in this case r by L. Like this seems like I have two poles here, right? But actually there isn't. But as this is a non-minimum phase system, I cannot directly compute the like Bode phase and gain plot, so I have to assume few things. So this means I have two poles at omega equals to r by L, which means I will get a slope of minus 90 degree per decade before 10 times that and after 10 times that. Okay, so it will start from 180 plus 180 only, then this will reduce and go to 0, because at omega equals to infinity my slope is 0. 180 minus 2 times 90 is 0. So this seems like I have two poles at omega p equals to r by L. Okay, and this is 10 times that, 10 times omega p, and this is omega p by 10. Okay, So this is the case, and this phase, right, this phase slope is minus 90 degree per decade. Okay, this slope is minus 90 degree per decade. So this is the case for this Bode phase and gain plot. So next one is almost similar, just the R and LR interchange. So again, number of independent energy storing element will be same, because L1 equals to L, L2 equals to L, and R1 equals to R2 equals to R. So again, order will be 1. Okay, I want to derive again. Order will be 1, and obviously it will be response exponential will be response will be exponential, and time constant will be L equivalent by R equivalent. So this will be L by 2 upon R by 2. So this will be L by R only. Okay, L by R. So next you can directly go to the this, right, initial and final conditions. So okay, I have to draw the circuit anyways, that is more difficult. What I'll do, I will just interchange the R and L this time, right? Okay, this has this something else, just hold on to copy this circuit, right? Here it again the same thing I will do. Like with intuition it is very difficult. I have to solve the circuit, then only I'll be able to comment. Okay, but how to solve the circuits I have explained you very well, right? So what will happen over here? Simply this R and this R will be it. So one thing is, you should watch the first 2 marathons, then only you will understand this, because here I am going a bit fast, right? I am explaining things very slow, very fast, because on those marathons I have explained very well, right? So I hope you have watched those marathons, then only you will be able to understand this marathon very well, right? Else few things may happen, be confused, like because why I am explaining little here, because I have already explained those in the previous marathon. So this L will be here, this R will be here, and this L will be here, right? Okay, so this is this arrangement. So now my VO is this, right? VO is this, and obviously at t equals to 0 plus, again this whole voltage will come across this, drop will be 0 over here, 0 over here. So what will be my VO? VO will be again this 1 volts only, right? 1 volts only. Okay, but this time positive or negative we have to see. But again, inductor will charge, again it will go to steady state, again same thing will happen. So initially flux is 0. Initially flux is 0. So as flux is 0, then what will happen? Flux is 0, hence my current IL of 0 minus is 0. Now is it equals to IL of 0 plus? We have to check. Like basically if I draw the circuit for t equals to 0 plus, this is 1 volt. So and the inductors are open circuit, right? Inductors are open circuit, and obviously this is at t equals to 0 plus. So voltage across this is 1 volt, voltage across this is again 1 volts. Okay, so basically what will happen? So voltage across this is 1 volt. So obviously VL of 0 plus is 1, which is finite and greater than 0. So it will be not equals to 0. Sorry, it will be equal, sorry, as this is finite, right? I'm just in some other mood. So as it is finite, it will be equals to 0. So basically it will charge, but what will happen again, some drop will occur across here, so inductor voltage will reduce further, so the rate at which it was increasing will reduce, rate at which the current was increasing will reduce, but still current will increase, hence the drop will further reduce here across the inductor, and at some stage VL will go to 0 and the rate of change of current will be 0, it will reach steady state. Okay, so but what will be the voltage VO, what will be the voltage VO? So if we compute here minus VO, and this is 0 volts drop, this is 0 volts drop, right? Current is 0 volts drop. Okay, so minus VO plus 0 minus 1 equals to 0. So VO of 0 plus will be what? Minus VO plus 0 minus 1 equals to 0. VO equals to minus 1 volts. VO equals to minus 1 volts, right? This is VO of 0 plus. Okay, this is V of 0 plus. So this is V of 0 plus. Now what about infinity? Infinity, obviously VL infinity will be 0. So if VL infinity is 0, they will become short circuit. They will become short circuit. And this will be obviously 1 volt. Okay, and the whole voltage will be across the resistor itself. Okay, 1 volt, and this is at t equals to infinity. So basically what will happen over here? So basically if I compute my VO, I will compute here from here itself. So VO will be equals to 1 volt itself, right? Minus VO plus 1 plus 0 equals to 0. So VO will be 1 volt. This time it is going from minus 1 to plus 1, right? Minus 1 to plus 1. So how will my waveform look like? My waveform will look like this. It will go from minus 1 to plus 1 exponentially. Okay, minus 1 volt to plus 1 volt exponentially. What will be the equation? So this is basically 4 tau, and equation will be VO of t will be initial is minus 1 plus, not minus, sorry, final is 1 plus minus 1 into e raised to power minus t upon tau. So this will be 1 minus 2 upon e raised to power minus t upon tau. Okay, so this will be the equation. So now let's compute the impulse response. So can you tell me the impulse response? It will similar on, right? Along the similar lines, just it will be flipped. Okay, so again we'll just copy this analysis. Everything will be almost same, just IL0 minus will not be equals to IL0 plus. Cannot even copy this thing. And this is not even fitting, right? So I will just reduce the size right now. I will reduce its size. So basically here what is happening here, right? This time instead of 1 volt, this is impulse voltage. This is at t equals to not 0 plus, this is at t equals to 0. So a whole impulse is coming across these two inductors, right? Delta of t and delta of t. So they will be instantaneously charged to 1 by L of current. They will be energized to instantaneously 1 by L of current. So VL of 0 plus is not 0 plus, VL of 0 is delta of t is greater than 0, and obviously it is infinite, not finite, right? It is not finite. So this will be not equal. IL of 0 minus will not be equal to IL of 0 plus. So what will be VO of 0 plus? So that we have to compute right now. So what will be VO of 0? Okay, anything I missed in here initially? Did I miss anything for the impulse response? here, right? Initially this had impulse voltage across it. So what will be the voltage? This will be impulse. So also, like I missed this part, there will be also a impulse voltage, right? There will be also a impulse voltage across it. So this part I missed. So at t equals to 0, if I compute VO, right? T equals to 0, if I compute VO, so this will be minus VO. I am just applying the KVL, plus delta of t plus 0 equals to 0. So VO of t will be delta of t. Okay, so there will be impulse voltage, like output voltage will be also impulse will also come across the output. So where is it, where was the waveform? So here, right, I will have an impulse also. This one I missed, impulse of area 1. Okay, this is very important. So okay, I didn't even write the equation for this. I directly went, I was in too much hurry. So what will the equation of VO of t? The equation of VO of t will be del of t minus 2r by L e raised to power minus t upon tau. Okay, so this will be my impulse response. So one thing I want to show you. So simply if you integrate this, right, simply if you integrate this, okay, if you integrate this, you will get this, right? You will get this. Okay, you will get this. So impulse, like the impulse integration of impulse response is the step response. The differentiation of the step response will be the impulse response. So if I differentiate this, I will get this. Okay, I should get this, but this is telling me I will get a impulse in the negative direction. Is this really true? There will be also a u of t over here, that is fine, but like we can check later. Okay, this is like a control system talk, so we can check later. So let's come back to here, right? Here, here, right? So here, what is the voltage across the output? So now if I compute minus equals to del of t, so minus VO of 0 minus del of t equals to 0. So my VO of 0 equals to minus of del of t. So I have delta t in negative direction. Okay, and what about this case? Then, right, at t equals to 0 plus, it is getting replaced with two current sources, right? Two current sources. So I will just copy this. Copy this thing. Delta t will be gone. This will be 1 by L of current, this will be 1 by L of current. So obviously VL of 0 is delta of t, so VL IL of 0 minus, this we have done multiple times, is basically integration of 1 by L delta of t with respect to dt. So it will be 1 by L amps itself. Okay, 1 by L amps itself. So this is at t equals to 0. So obviously my impulse is gone now, not 0 0 plus, impulse is obviously gone now. Okay, and now what is the voltage here? So again I will choose the resistive path, right? So here current is 1 by L, so the drop across it will be what? Drop across it will be R by L. Okay, and across it will also be R by L. So now if I apply KVL, I'm starting from here, going this and then ending here, right? So I'm starting from minus VO of 0 plus R by L, then plus R by L equals to 0. So VO of 0 plus equals to 2R by L. Okay, so VO of 0 will be 2R by L, and obviously at infinity what will happen? Everything will go 0, right? Everything will go 0. So this will be short circuit, this will be short circuit, and all of them will be 0 itself. This is also short circuit. There is no source free network, so everything will go to 0. Goes to infinity. So VO of infinity equals to 0 volts. So how does my waveform look like. So my waveform looks like this, right? It has a negative impulse, one area of 1, and then from plus 2 by L to R by L it goes to 0. It goes to 0, right? It goes to 0. So this is my waveform basically. So what will be the equation of this waveform? Equation of this waveform, VO of t will be minus delta of t plus 2r by L into e raised to power minus t upon tau. So in the previous case, have I written it correctly or not? I just want to check. Yeah, this is correct, and this, yeah, this is also correct. Okay, so let's talk about poles as 0 again, right? We'll do the same thing only. I'll just bring the circuit over here and I will compute the voltage at V2 of S, which will be, this time it will just be opposite. This will be R by R plus SL into VI of S, and V4 of S will be SL by R plus SL into VI of S. So VO of S equals to V2 of S minus V4 of S. So this will be equals to R minus SL divided by R plus SL again, right? 0 non-minimum phase system. So in general we don't draw the Bode plot for non-minimum phase system, but we can, right? And that is what we're doing. So this will be this, and because like we can't recover from that, right? We can't recover back to the transfer function because we will get confused. I have already explained this in my Bode plots lecture video. So this, right, this will be, if I take R common on both sides, this will be SL by R, and this will be 1 plus SL by R. Okay, so this will be my times VI also. So what is my VU over VI of S? My VU of S over VI of S is basically what? So this will be 1 minus SL by R. Yeah, this will be 1 minus SL by R divided by 1 plus SL by R. So now if I compute the magnitude will be what? Magnitude will be 1 again, right? This is a non-minimum phase system again, right? This time the difference is, where am I lying? The difference is on the coordinate itself. So what is the difference? I'm lying in the first and the fourth coordinate, so that is very important. So this is my plus and plus, so x is positive and y is positive. This is my plus and minus, x is positive and y is negative, x is positive and y is negative. Okay, so what will be this? So what will be this? I just lost in thought. So h of magnitude of j omega, right? What will be it? It will be simply 1. Okay, it will be simply 1. An angle, like you can do the square thing, it will be 1. Angle will be just a bit tricky. So obviously what is this contributing? This is contributing minus theta, right? Minus theta, because I'm going clockwise direction. So minus theta means minus tan inverse omega L by R. Okay, seems like I have a pole at L by R. Okay, S equals to minus R by L. Okay, and this is anyways again contributing minus tan inverse tan inverse omega L by R. So this will be minus 2 tan inverse omega L by R. This is angle of h of j omega. So basically what will happen, my Bode gain plot again, right, will be 1. I have already plotted it. It will be always 1, always 0 dB, because it is always equals to 1, magnitude is always equals to 1, and this phase will be what? So initially, if at omega is 0, my angle of h of j omega is what? Angle of h of j omega is minus 2 tan inverse omega L by R. Hence, initially my like angle will be 0, then it will go to negative, then it will go to 0. Okay, then it will go to 0. So this will be what? This will be minus, not 45. This time I have two. It seems like I have two poles at omega equals to r by l. Okay, not really, but it seems like that. Minus 90 degree per decade, and this side, this is simply r by l, and this is r by 10l, and this is 10 r by l. Okay, so this is what? This is minus 180, right? Like tan inverse infinity is 90, and I have to, so this will be minus 180 degrees. Okay, minus 180 degrees. So yeah, this will be basically it for all of the impulse and step response of all the RL circuits. So in the next marathon, if you guys like this video enough, I will bring the current excitation, okay, for step and unit impulse, like current excitation with step and unit current sources for RL circuits. So it all depends on you, how much you like the video, how much you share, else this video will also go private, okay, because I'm doing this much hard work, so in return I also expect something. So yeah, I hope you like this videos, and I will see you in the next video. Thank you for watching.